This conference is brought to you by CodeStack, React and React Native development experts.
Hello. Hey, good afternoon. Great to see you all here again at the second day of React Native EU Conference 2022 edition. Yeah, give it up. Yesterday, we had 11 topics from 11 great developers, great speakers, and today we are going to top that with another 11 great topics from great speakers. I will not keep you waiting for any longer, and I'd like to invite on the stage from Stripe, Charlie Cruzan.
All right. Hi, my name's Charlie. I'm a software engineer at Stripe. And today I want to talk to you a little bit about accepting payments in your React Native app, why you might want to use Stripe to do it, and then kind of finish off with a summary of the React Native story at Stripe. Cool. So to start off, I've got a really tough question for everyone, which is why are payments important? Hopefully, most of you got the answer. It's to make money. So obviously, we need to make money without collecting payments. Users can't pay us for all of our awesome features and also the fun bugs that we ship. So that's basically it. Yeah, talk is over. I'll see you guys later. No, I'm just kidding. So yeah, maybe that question was a little too easy. Let's ask a better one. So what makes payments difficult in an app? So first of all, payment flows are usually pretty complex. They're involving a lot of asynchronous communication, a whole bunch of error states. You got to think about retry logic and validation, fraud, disputes. So there's kind of a lot to think about. On top of that, security is also a really big issue with payments, obviously. So the more data you collect from your users, the more appealing you are to some sort of attacker. And that threat obviously grows enormously once payment data enters the scene, since it's so much more volatile. And so that's why the payment industry has something called PCI standards, or payment card industry standards. This is essentially the most boring topic I could ever talk to you about, but it's just rules for how to deal with payment data and store it. So ideally, you avoid this completely by only collecting payments, but not any payment data, which is a little complicated, but we'll get back to that later. Also, payment flows, just complex, like I mentioned earlier, so that means they're hard to test. End-to-end tests are essentially your only option, and even then, it's hard to test every payment method that you want to use. Speaking of payment methods, if you are operating globally, you have to build out support for a lot of different payment methods. So not many developers want to build multiple checkout scenarios for all the different payment methods out there, of which there are a whole lot. So before I started at Stripe, I was very much the ignorant American that assumed the whole world just used credit cards. Thank God I'm not a business owner, because if you make that assumption as a business owner, you are alienating a huge portion of your user base, but you're missing out on a lot of potential revenue as well. So these pie charts that are up there kind of show the breakdown of different payment methods per country. The UK is exactly what I kind of stupidly thought the whole world was like, which is most people use credit cards or Apple Pay and Google Pay. But then you look at a place like Malaysia, which is 50% bank transfers or bank debits, and then you move to Mexico, which is a whole bunch of like cash, and OXXO, which is like this voucher that they use over there, which Stripe now supports, which is great. But yeah, so back to what makes payments difficult: coding up the checkout flow for all those payment methods, having a ton of different screens, not super fun, not super easy. And yeah, kind of this list could get really long: optimizing conversion rates to make sure customers do check out, validating that card data, handling fraud and disputes. So yeah, long list. If you're excited to handle all of this by yourself, you are 10 times a better developer than I am. I would rather not think about any of it, just work on my actual product and not have to think about a checkout experience. So let's assume, for the sake of this talk, that you're like me and you'd rather not spend all your time reading financial institution documentation. And wouldn't it be cool if we could just accept payments and not really worry about any of the stuff on that last slide? So spoiler, that's exactly what Stripe attempts to do for you. And I think we actually do it pretty well. I am heavily biased, so let's go through some examples of what Stripe React Native does, and you can kind of decide for yourself whether or not it's useful. So we're going to go through two examples of collecting payments. The first one is you're going to build out your own checkout page, basically. If you want that, that's great. And then one that provides a fully built out checkout solution for you. So if you've ever done any web development with Stripe, this is very similar to Stripe Elements, which is individual components that you'd embed in your web page, versus like a hosted checkout where Stripe handles all of it for you end to end. Both solutions are great. Both take a couple lines of code. It all depends on kind of what you need and how much control and work you want to make for yourself. Okay, cool. So we're just going to jump right into the first component, where you're just going to build your own checkout screen. So we have a really plain app here. As you can see on the right, we are selling sweet potatoes. The UI is beautiful. I'm an amazing UI designer. And the customer knows what they're buying. So now we just need to let them buy it. All right, cool. So now, as you can see on the right, there is a place for a customer to input their card info. So let's kind of step by step go through what we added. First of all, we have our Stripe provider component. Pretty simple. You are providing your Stripe publishable key, which is like any other API key. Component takes a little more options, but this is really all we need for now. And then this essentially just initializes the SDK for us. So next up, we have our card field component. We can collect card details here. It validates the card number in the moment. It's stylable, customizable, all that good stuff. And then, yeah, we've got just regular React Native button. But the two questions are, what is this buy function that we're calling on press? And then what's this loading Boolean that we're using for the disable function? So yeah, let's take a look at what those are. Cool. So here's all our Stripe logic for this component. We have a hook here at the top, which is essentially just helping us import what we need from Stripe. So this is the method we need, confirm payment, and this loading Boolean, which essentially tells us, like, is this confirm payment method running? So that way, if it is, we know disable that buy button, don't let the user spam us with a whole bunch of processes. We don't really want that. Cool. So now kind of walking through this buy function that we have, before we confirm this payment that we want the user to go through, we need to know what exactly it is we're confirming. So Stripe handles this with something called payment intents, which is exactly what it sounds like. It is a customer's intent to pay you. So this includes like all the relevant data, like how much they're paying you, what currency it is in, and then any metadata about the payment. So yeah, we have to grab that from our kind of fake server that we have going on here, because you don't want to create those client side just for security reasons. And then we can pass that secret that we're getting back from our server to confirm the payment intent along with our payment method type, which in this case is a card. And then voila, you're done. You've accepted a payment as long as you don't get an error back. So the Stripe SDK is smart enough in the background to kind of pull that data from the card field. You don't have to like link it or anything like that. And this means that you aren't directly handling any payment data. So PCI compliance is a breeze. You essentially just like check a box on a form and you're done. And yeah, to prove I'm not hiding a bunch of work in that fetch payment intent secret thing that like you'd have to do on the back end, this is all of the server code you would need. You're essentially using Stripe's Node SDK. It's like 5 lines of code. Create a customer, create that payment intent for $50 or 50 USD, and yeah, send that back. Super easy. So this flow has a whole bunch of pros. We have very little code to collect payments, which is great. We're not handling card data, so PCI is really easy. Security is easy. We're getting that verification of card details right in the card component, and then a whole bunch of customization options if we want them. But it's still pretty bad in a lot of ways. So first of all, the same thing I was talking about before, we only have card support in this. A person can't input their bank account number into the card field and pay that way. If they want to come back and buy more sweet potatoes, they have to input their card again, or we have to create some sort of like logic to remember their payment method. We have to design this checkout page, so that's a lot of design work to do. And then, yeah, again, we have to re-implement this for every new payment method. So what if we could get rid of all these cons, make our users' lives better, and also make our lives as developers easier? So let's say we have a couple new requirements for a V2 of our checkout page. So number one, we don't want to spend time creating some custom checkout screen. We just want a button, and that's it. We also want to easily support every payment method that's supported by Stripe out of the box. And if Stripe adds some, we want to get those for free, and we don't really want to have to like update our app and make our users re-download a new version of the app just to get a new payment method. And then finally, we want our customers to kind of have a great and seamless checkout experience, meaning we remember their old payment methods and kind of stuff like that. So we're going to start over with our component here. We're still initializing Stripe with our Stripe provider, but we've obviously taken out the card field component. We just have our buy button. So let's kind of take a look at what this buy button does now. Okay, the video goes very quickly, but you can see that the payment sheet kind of gets launched, which is exactly what the payment sheet is. And now we're going to take a look at the code that's kind of behind the payment sheet. So yeah, the payment sheet is a self-contained checkout experience presented in this bottom sheet and provides kind of like a streamlined, reliable experience across Android and iOS. The code for it, really simple, but we can go through it step by step. So number one, we're using that hook again from Stripe to grab everything we need. So we've got the init payment sheet function, the present payment sheet function, and that loading Boolean that I talked about before. Cool, and in our setup function, which you'd call like in useEffect or beforehand, whatever you want. We're grabbing params from the server just like we did last time. Although this time we have 2 new params that we're grabbing. I'll kind of show you the additional code that's necessary, but it's really little. Yeah, then we're calling initialize payment sheet with those parameters. Really, really easy. And yeah, once our customer clicks buy, they click buy, we present the payment sheet. Once it's closed or canceled, we resolve either with an error or the payment was successful. And that's it. Super easy. We had basically no UI work to do at all besides that button. And yeah, here's the server endpoint we'd theoretically be hitting. It's essentially the same thing as last time, except we added this ephemeral key logic, which this key gives the Stripe mobile SDK a bit more power, so we can send that back along with the payment intent client secret, our customer ID, and then yeah, you're good to go. That's your server code. So maybe a lot of you are thinking, okay, cool, that's great, but I really don't like the idea of having like a separate UI. I'd rather control all my UI, stick with the card field, and spend that time building new checkout screens for like SEPA debit or other payment methods. So that's fine if you feel that way. But I do want to get you to give me a chance to kind of go through a couple more reasons why to use the payment sheet and why it's so cool. So first of all, integrating Apple Pay and Google Pay, super easy, barely any work. You just have to pass some JSON into the init payment sheet function, and then boom, on iOS you get the little Apple Pay section for your customers, and on Android you'd see a similar Google Pay option. Plus, the payment sheet allows you to kind of customize your checkout experience in a lot of different ways. So one of these would be this custom flow prop. When you pass it as true, you separate out the steps of actually picking a payment method versus confirming the purchase. So this way, you kind of have more control over the actual checkout portion. And mostly what Stripe is handling for you is like payment method creation. So if you want to do some sort of checks after a payment method was added, but before checking out, you can do that really easily. Yeah, stuff like that. And then finally, appearance. So one of the biggest pieces of feedback we got about the payment sheet when it was originally launched was, this is really cool for like a proof of concept, but the UI doesn't really flow with our app at all. It feels really jarring, yanks the user out of this like immersive app experience we've got going on, and that really sucks. So luckily now there's a way to handle that as well. Again, just like really easy JSON to handle, and you can control the look and feel of your payment sheet super easily. So maybe all my sweet potato buyers are big users of VS Code's One Dark theme, and so now they can go to my checkout screen and be like, oh my god, I'm basically in VS Code, this is amazing. So yeah, that's cool. Okay, finally, and this is probably payment sheet's like biggest upside. Oh, this is a video, and it played when I tested it, but now it's not playing, which is so unfortunate. But, okay, we'll see what happens. Basically, payment sheet's biggest upside is adding new payment methods takes no client-side code whatsoever. So you don't have to deploy or anything like that. You just go to your server, and where you're passing payment method types card in that first block there, you just add more strings of payment methods that you want to collect. And essentially, that's it. So now you're collecting more payment method data or payment method types without deploying a new app version or asking your users to update. And so that's really, really great for you, for your users, for Stripe, for everyone. So, oh, okay, yeah, here's the video. Not gonna let the whole thing play. It's basically just me typing in different words. Not super interesting, but you get the picture. Super easy to do. And yeah, so if your payment sheet supports multiple payment methods, this is what it looks like. Your payment options are all displayed in this carousel for your users to choose from. And then on top of that, you don't have to worry too much about app review. For those of you that haven't integrated a payment kind of checkout experience in your app, app review is really particular about where and how big Apple Pay is displayed. Same with Google Pay. You don't have to worry about this. It's annoying to get a rejection for that, but yeah, you won't have to worry about it. So that's great, and that's basically payment sheet in a nutshell. So now that we've gone through why you might use Stripe React Native, I wanted to briefly, really quick, talk about the story of React Native at Stripe. So I'm really happy to say that React Native is a core piece of Stripe's mobile offering. We're starting to consider it now from the very beginning of designing mobile flows rather than kind of as an afterthought of the iOS and Android SDKs, which is really great for React Native as a whole, or my experience as a React Native developer. And then, yeah, we've seen more and more merchants at Stripe move or start on React Native, which is really exciting because it kind of proves how React Native is just growing in popularity, not just in smaller use cases, but even some of the biggest apps out there. And some of like the new payment methods that Stripe will launch, like we want React Native there from the get-go because we have this big user that's on React Native that really wants to use it. So that's just been really exciting to see. And then, yeah, React Native kind of follows really closely or essentially in step with our other mobile SDKs to the point where they're all in step feature-wise. So no platform is left without, no developer is left without. And yeah, really cool, featured really prominently in our docs. This was just like a kind of cool thing to see happen at Stripe, which is it has like the web, iOS, Android, and now React Native. So yeah, kind of great. Like React isn't even up there. It says web, but it says React Native, which is so cool, I think. So yeah, that's the React Native story at Stripe. So I bet you're thinking, oh, okay, cool. So Stripe provides a payments library for React Native. Makes total sense. Like Stripe is a payments company. But wait, there's actually more. Stripe isn't just a payments company. So there's a lot more to it. First of all, this is still sort of payments, but the SDK comes with first-class Apple and Google Pay support, including kind of finer details like push provisioning, which is adding a new card to your user's digital wallet. This is actually a really complicated flow natively, and I don't really understand why, but in React Native, it's as simple as just rendering this add to wallet button component, and you're done. So Stripe issuing makes that really, really easy. Next up, we have a new Know Your Customer Stripe React Native library, which is Stripe Identity. And so this allows you to verify the identities of users using an ID card or a passport, something like that. This is really useful for anyone that's familiar with Stripe Connect. So let's say you have like a rideshare platform and you want to verify your drivers or something like that. You would use Stripe Identity to kind of scan their ID or something like that. And yeah, let them use your platform. Cool, and then, oh, okay, well, that's the video, but yeah, scanning ID, super, super fun. Okay, and then point of sale. So brand new product for Stripe. I actually don't have a demo for it, which is unfortunate, but is Stripe Terminal. And Stripe Terminal is a point of sale, so you can collect payments in person, right on your phone, like tap to pay and all that kind of stuff. Like I said, I don't have a demo with me, but I will link the repo, because it's open source, in Discord afterwards. So yeah, and there's more on the way that we're working on. I feel like really the React Native story at Stripe is just starting and kind of picking up speed as we go. So I'm really excited to see what else Stripe starts to do in the React Native sphere. And yeah, thank you very much for taking the time to listen to this talk. Thanks to CallStack for hosting an awesome conference so far. Excited to see the rest of the speakers today. And yeah, I'll be around to answer any questions or gather feedback. If you've used Stripe React Native, definitely come and talk to me. Would love to hear what you thought. That's it.
Thanks a lot, Charlie. Such a complicated topic explained with such ease. Great speaker. Thank you so much. Another topic for today is dev workflows with headless content management. Time to reattach the head. From Zerv, it's Eric.
you. Wow, I'm so excited to be here. My name is Vicenti, and I'm here to talk about headless content systems with React Native. And I've been super lucky in my career to work on a number of awesome open source projects, from the development process to the open sourcing, including React Native, React Navigation, and Docusaurus. But in recent years, I've been thinking more broadly about how we as a community build apps. So who are we? Like, this is us. We're like gremlin developers with laptops. It's really, really cool. And what do we actually maintain, though, as a team? We maintain a code base, which goes through a platform-specific process to build and deploy our application. And we also maintain a database for our users, which is tightly integrated into our application. And what do I mean, though, when I say us as a team? Actually, I'm not just talking about the developer here. I'm talking about how clients and executives and creatives like marketing people and designers are all wanting to have control over the application that we are expected to build and deliver. So, as developers, though, we're the only ones who know how to push and deploy the application, right? So in practice, it often looks like this, where the creatives and the executives have to go through the developers to make changes in the application. And this is not really a desirable process for anyone involved. This can be exhausting, and everyone would rather that the engineering team could focus on delivering new features for our users. So that's why I think we should introduce a new thing here in between our two things that we're maintaining. I think we should have a content management system. Now, a CMS allows us to basically address this problem here where the non-technical people have to go through the engineers, and instead it allows the non-technical people to go through a dashboard that's able to directly make changes in our application. So that's why I want to talk about content management systems today, is because it's a big problem in our organization, and it really weighs down the engineering team by having to go through this workflow. So content management systems, though, are not new. I'm sure you're aware of this, right? They come from a world of the web, where the content management system database and dashboard are tightly integrated into your application. They actually provide the application itself, the application that the user sees, right? Like you probably know of WordPress, this incredibly popular monolithic content management system. But there are some troubles when we have the content management system like this, right? Like, I'm talking to a very technical audience. I'm sure you're all aware of computer history like I am. Like, years after Al Gore invented the internet, Tim Apple invented the App Store, right? So the problem is that a content management system here is not able to very easily send data to the applications that are in the App Store because they're tightly integrated with the web experience. And that's not the only problem, because you've got technical people like engineers who really struggle to own the application that they're expected to work on because it's so tightly integrated and the developers can't choose their own tools when it comes to building the actual application. So that's why in recent years, headless content management systems have become more of a thing. And I think headless content management systems are great, but I just want to quickly acknowledge that the application that you're developing is the head that we've just removed. Like, okay, whatever. But the headless CMSs solve problems, right? Because they're a standalone dashboard and database for your content, they allow you to deliver content to applications, and of course, developers are able to use their normal build and deploy process to deliver their application. Now, there are a lot of content management systems out there, but surprise, surprise, I'm working on a content management system called the Zerv content system. And before we get too far into the fun stuff, I just want to show you what it's like to have a very simple headless content system. So, ready for a quick demo. So I'm going to come into the dashboard and create a store, which is called demo. And I'll create an entry, which is going to be some text that's showing up on our website called headline, right? And headline, we can choose various different JSON data types here. And I'll say that this is a text. I'm going to save the schema, and we're going to come in, actually create our headline. Okay? So we've created some very simple data in our application, and of course we can access this data over an API. So here's the URL basically for the store, and I'm going to drill into this headline URL and we see the value for it, but we can also go and query for the schema. So this is querying for the actual raw JSON schema of our data. Okay, pretty simple. Let's see if we can crank it up a notch, because our marketing team wants to manage content that's on our website and in our application, like a list of frequently asked questions. And these are the data types that we have available, but it's more powerful if we create a reusable schema for our store here. So I'll say that we're creating a question response, which is, a question and an answer. So this is an object because, question and answer are named things inside of it. So I'll go ahead and add the entry for question, set this to be text, and I'm going to do the same thing for the response. So really simple, we're creating an object for our FAQ basically. Now we can go back once we save the schema. Let's go ahead and add an entry for the FAQ. So I'm going to pretend to be the marketing person now, right? So let's say that this is FAQ is, we could put this as a question response, but it's actually a list of question responses. So for items, I'll say that the items are question response items. And this is the schema for our entry. So now I get to play marketing person and come in and add some questions like, what is Zerv useful for? That might be a common question. Here's a response. You'll see this again later. How can I show my support for Zerv? Right, here's another question. So now that we've saved this, we can go ahead and query for this data, of course, from the backend, right? This is all available through a JSON API. Okay, so that's pretty fun. This is what it's like when you have a very basic content management system. This is, at least it works, but the problem here is our application, it's able to, of course, query from an API, right? We're all developers, we're all familiar with how to query application data. Unfortunately, when we query data from this API, our application does not know what type it is. So there's a type safety issue where it's basically just getting arbitrary JSON that we need to program against. So how are we going to program against this thing where we're just getting this back as basically any data or unknown data? Well, because we have an API that allows us to query for the schema in the application, we can actually run a command line program that will code gen a client for us that's a type safe client that understands the data that our application will get from our database. So this is where it gets a little bit more fun. I'm going to jump into a demo where we'll see what it's actually like to use the Zerv CMS in a friendly way that gives us a type-safe interface to it. So here's a simple Next.js application, right? It's our frequently asked questions. And it's showing, this is the content, basically. And here it is, it's hard-coded, right? So how easy is it to deploy this content? Well, you need to know how to use React, and you need to be able to refresh, or you need to be able to deploy your application. But we want it to be the data from our CMS. So let's go ahead and start by installing the Zerv CLI. And we're going to install all of our dependencies here. We're going to get the Zerv CLI, and while we're at it, we're also going to get the Zerv client, which is going to be the runtime client. And the runtime client is a very thin library. So we're also going to go and install React Query, which is powering the client right now. So that's a pure dependency that you need to install into the application as well. And once we've installed these dependencies, we can jump into our package.json, and then we're going to configure it with a little bit of configuration. So what does this configuration look like? Basically, the Zerv field has a dynamic sync, which means that this is content that's going to be synced to your client. And the demo store is what we're calling it in our code base. So this is a local name that's going to be basically the name of our client. And then here's the URL of the store. Specifically, you can see it's got the username and the store name in there. And then when you run Zerv sync, it creates the client for you, right? Pretty fun and straightforward stuff. But I'm going to go ahead and add this as a prepare script. So that way, whenever I run yarn in my code base, it's automatically going to run Zerv sync. Okay, so now we can go ahead and sync it. Here we go. It quickly grabs it from the store. And you can see it's listed some files that it's gone and created for us. So what do these files look like? Specifically, the index file has the type safety and has all of the interesting stuff going on in it. So here is the schema for what the question response is. And if you look down, you can also see what the file schema is, which is a list of question responses. Okay, pretty fun. Now we have like a type-safe interface in our application. Before we can use it, though, we do have to set up React Query. So that basically means having a query client provider in our application. And now that we have this React Query sort of environment installed, we're ready for the fun part. We can use FAQ, which is coming from our custom store. And here we're just using the React Query API. We get data, we get is loading, we're able to iterate over our data and punch in the data that's coming from the store, which is the question and the response. And then we also have the $ key, which is a built-in key that's being used to deduplicate, tell React the order of everything in your store. And we also need to add error handling here. I'm sure you've noticed. Don't worry. I know that we need to add error handling. Use FAQ, though, is just using React Query out of the box. So you can actually pass in everything that you would pass into a React Query query, the query options, into use FAQ, or you could get the error out of the same object that it returns. Okay, so pretty fun. Now we're able to go ahead and load our data from the CMS. Pretty fun. And obviously what's important here is that we're getting it back in a way that's type safe and is going to be a little more robust for us than just a normal JSON API. So that's fun. We're still just talking about a headless content management system. And the reason why I consider this headless, right, is because you had to write all of the code yourself. You had to anticipate everything that was going to come from the CMS and present it manually in the application, right? So this could still be a little bit exhausting. Now, how can we come back and rehead this CMS? Like, I want to provide some value here so that you don't have to anticipate everything that your content people are going to want to put into the application. So how about we just show you what that's like? Because we already have this example with FAQ. So what happens in the FAQ when the content person comes in? Of course, they've been setting it up in the content management system, and now they want to change this text in a way that you didn't anticipate, right? Maybe they ask for a really simple request, like this is text that's being displayed to humans. Like, why can't they just make some of it bold? Or why can't they have an inline link in this text? I mean, the problem, I guess, is that this is not text for humans. This is like an actual string, right? If we look at our code, this is only ever a string. Like, wouldn't it be nice if this were not an actual literal text, but a human text? So I'm going to go into the store settings and turn on a schema that's an experimental schema called human text. And from here, I'm going to reset a little bit of my data. I'm going to wipe out this entry. And more importantly, let's go into the schema for the question response and say that the response here is an actual human text. Ooh, what's that going to look like? All right, so we're going to save this, go back into our entry, and again, I get to play content person. I get to play marketing person and say, all right, what are we going to do as a marketing person? Well, here it is. We're setting up some data. We're saying, we could put a human text as this field, but again, it's a list. And it's a list of these question response schemas that we've created. So, of course, the marketing team is at it again. They're trying to figure out what to put in here. And we're going to put in the same content, but we're going to emphasize it. And you can see that there's an actual, not rich text editor. I wouldn't call it rich text. I would call it a human text editor. The developer will still control most of the aesthetics here, but the content is defined by the content person. So here the content person is making certain stuff bold. I don't know. They're not very creative here. Okay, so, and of course, the main reason is they wanted to be able to embed links inside of this content, right? Like they just want links. Is it so much to ask? They just wanted links. But you said it's a string. You were explaining that it's not text for humans. It was text for computers. But finally, we have a human text. We can go ahead and add some links. Okay. So again, this is still entirely headless workflow so far. I'm going to rerun Zerv sync, and it's going to copy the new schema into the application. And this is what the schema looks like. The question response is now referring to this built-in schema type. Now, before we can actually render this to our users, unless the developer wants to go and do it manually again, we can go ahead and install Yarn, install React Native content from Zerv. Okay, here we go. Once we have this, we can replace this text. You can see it had a type error because it was a string, and it's now no longer a string. So let's go ahead and punch in a real thing it's going to check out with a type safety perspective as soon as we import it properly from Zerv React Native content / human text. Okay, so this is pretty exciting. I know earlier I was showing that this is a Next app, and I just realized that we're at a React Native conference. Wouldn't it be nice if I were demoing this in React Native? But actually, let me scroll down here. It turns out, yeah, this is actually a React Native app. So let me just run it with Next, or with Expo, of course. Here it is running on iPhone, and I haven't forgotten your favorite operating system, Android. Let's go ahead and run it on Android as well. As you can see, it loads up the human text. There's certain amounts of text in there that's bold, and there were some links. This is also very highly customizable. The links are working, it seems. That's nice. I don't know if those links look nice to me. So this human text is an actual React Native text component that you can customize like any other text component. So the developer still has a lot of control here, and basically all the behavior of human text is totally controllable by the developer, and in fact, you don't even have to render the human text component if you want to manage that stuff yourself. So anyways, now the developer can enjoy content that they didn't have to anticipate ahead of time. So this has been a quick, fun demo. That's it for the demos of the reheaded content system. So I'm pretty excited about this. I think this has been pretty fun. So this is a quick look at what it's like when you rehead the content system. And we're keeping things pretty simple right now. This is very basic. So for now, this is just a human text. But eventually, we can build higher level components like page. And a page might include images and blog post like content. And there would be associated views inside of the Zerv dashboard as well as schemas for those things. So don't get too excited yet, though, because I've only shown you Zerv on a web app. And I'd love to show you on a mobile app, but it's not quite ready. But I am working on building a version of Zerv for the app stores. And I think this is super important. And it's not like I would say that your marketing people and your executives, like they're just always on their phone. Like I would never say that. I would never say that. But seriously though, this is for developers because this is something that developers need. You need access to the content in your applications, right? Maybe you're using this for a feature flag and you've been working all week on building this new feature for your application. And on Friday night, you're out drinking hours after shipping it to production. And for some reason, your phone starts blowing up, and apparently all the users are experiencing a broken experience. And, are you going to go run home to your laptop while you're half drunk trying to fix that? Or are you just going to pull out the application on here because you're a smart developer, you anticipated this might happen, so you put all of this behind a feature flag on the Zerv content system, and you can turn this feature right off. And then probably the next round of drinks are on you, okay? So this is Zerv. I'm really excited about it. I hope you're not excited about it just because you've seen some cool demos and there's the promise of a mobile app. I think we should think of these things in a broader sense. Why is this thing going to be relevant years from now and not just some cool thing that's, on stage right now? So to get the elephant out of the room, I want to mention that Zerv is on GitHub. Now, I think this is really exciting, but you shouldn't be excited just because it's on GitHub, because a lot of things are actually on GitHub that aren't really that open source. So how are we going to put this on GitHub? How is this going to be published, right? Maybe it's going to be a source available project? Maybe? No? Do you consider this a SUS available project? Anyways, a lot of projects that are content management systems will publish their clients on GitHub as open source, right? Should Zerv entirely be open source or just the client? And there's a bunch of other ways that people will publish open source that make me a little bit uncomfortable about them in the long term. There's a lot of open core projects. And open core is pretty financially sustainable, and yet the open source project has a limited growth because there's all sorts of proprietary pieces of ecosystem that constrain it. And also, I'm not very spiritually aligned with a copyleft license. Because copyleft projects they force you to open source them if you make changes to them. And I want you to be able to fork this thing and entirely have control over it, do whatever you want with it, turn it into your own product. So I'm really excited to say that Zerv is properly open sourced. Ooh, so what does that mean? I mean that it's open sourced under a permissive license. And to be specific, I mean it's open sourced under Apache 2, which is a lot like the MIT license. It's kind of like if the MIT license were written by lawyers instead of being written by students. I don't know. So that's why I think the Zerv content system is super exciting. And I think that, like, for you to get an understanding of it, I mean that Zerv is basically my life. Like, my identity right now is basically digital nomad and creator of Zerv. Like, that's it for me right now. But sadly, I can't work on Zerv forever because eventually I'm gonna die. I hope you don't find that funny, by the way. All right? I don't find that funny at all. But more urgently than that, actually, I'm gonna run out of money. Like, I need to figure out how I can make this sustainable. So I'm looking for business models and I'm looking for investors who can help sustain Zerv as an open source business. So what's the first business model that I'm gonna go for, right? I'm going to offer Zerv as a paid hosted service. So because self-hosting, of course, is possible, it might not be easy, and a lot of people just don't want to self-host the service. So I'm going to offer a paid hosted service. And I think this is a really good business model up until a certain point of growth when some service like Amazon Web Services comes in like a bully and literally tries to take my lunch money. But if that happens, it means that Zerv has been highly successful and we can move on to other business models. So Zerv will be a paid hosted service, but, well, I haven't built a billing system yet, but more importantly than that, I really want to get it into people's hands as easily as possible and let you all try it. So this is appropriate now for you to try on your side projects, and I'd love for you to give me feedback. It has some rough edges. I would not say it's ready for production business use. And I'm going to leave it running as a free service for at least the next 6 months up until around April of next year. And I'll give you 2 months of notice before I shut it down. And at that time, you can always download it and self-host. So it comes with no guarantees. But if you do want some priority support and private infrastructure, get in touch with me and maybe I can put you on a paid plan a little bit earlier. So the alpha is live today, and I'd love to hear what you think. And before I wrap up, I want to talk a little bit about where Zerv is headed. So we've talked about how Zerv fits into your team's workflow, right? It's a new content management system. Maybe you have other content management systems, but Zerv is hyper-focused on being just a content management system for simple JSON and text. And I really want to emphasize that I'm focusing on making that an excellent experience before moving on to other things. But I also can't wait to add fun support like multimedia, images and videos, and low-code features for your non-technical people to add features to your application in a way that integrates well with your actual code. So I think it's going to get a little bit bigger. And also, the thing is users have content too. And I'd love to support things like authentication and like real-time database updates as well. And I'm not thinking about any of this stuff in a silo. I'm trying to think about your entire experience of building an application. So ultimately, there's going to be a lot of growth from here. And again, I'm not thinking about just the developers either. I'm thinking about the non-technical people as well on your team. So this is a little bit about like where I think Zerv can go from here. And that is why I think you should be excited about Zerv, because I've given you a broader picture of the project, not just some fun demos, which I think are incredible, but I'm really, really dedicated to this project. So you're welcome to try the free alpha. I'd love to have your feedback, and I would also love to have any contributions if you're interested in contributing in any way. So if you can check out the documentation and the alpha, you can do that at zerv.app. If you want to show your support, I'd love to see your star the project on GitHub, follow along on Twitter, and Yeah, that's it. I want to give a really deep thanks to all of you for being a part of this really incredible community. And thank you so much, React Native, and thank you, CallStack, for hosting us.
Wow. Thank you, Eric. That was amazing. Wow. Great product. I think I'm moving all my demo applications from Google Sheets to your product. And for the next talk, it's another one about headless, and it is Headless Flipper, embeddable mobile dev tools for your CI and beyond. From Meta, Andrey Goncharov.
Hello everybody! Today we're going to talk about Flipper, a debugging platform for your mobile and any kind of other hardware. Over the last year, we've been working relentlessly trying to reimagine what Flipper is and what it can do. Flipper is known to be an Electron-based debugging companion that you start on your laptop, you connect your mobile phone or something else, and it just fetches some data from your mobile phone for you. And what we envision Flipper to become, we want it to be a crucial part of your CI infrastructure. We want it to be a universal device bridge for any kind of hardware that you could use, potentially. But before we get started, let me say a few words about myself. My name is Andrey. I currently live in London. I work at Meta maintaining Flipper full-time. And our plan for the day is to cover what Flipper is, talk about how we're enabling programmatic access to Flipper, also known as headless mode, and how you can benefit from it. And last but not least, how we use the new headless Flipper at Meta. And without further ado, Flipper is a platform for debugging iOS, Android, and React Native apps, visualize, inspect, blah blah blah. This is clearly a joke. Hopefully some of you had a good laugh. So yeah, Flipper is basically Chrome DevTools for your mobile device and any kind of other hardware. Yeah. This is Flipper doing some layout inspection of some arbitrary mobile application. This is also Flipper inspecting network requests going somewhere, in this case npm.js. And this is also Flipper fetching the logs from the device. And this is also Flipper. This is our not so secret testing plugin, which basically just plays a game of tic-tac-toe. So in other words, a Flipper is just a device discovery service with a message bus. And Flipper wouldn't be Flipper without its plugins, which are the most important part of Flipper. And at this point, let's take a look at how it all works, really. Say we have Flipper and some mobile phones, 1, 2, 3. Flipper starts ADB for Android, IDB for iOS, or Metro for React Native to discover all these devices. And once it discovers them, it displays them in some hopefully nice, I hope you like it, UI. For clarity, let's name them ABC on the left, ABC on the right. Hopefully left and right still in the same place for you. Whatever. So yeah, we have all these devices, and once Flipper discovers all the devices, it can start the plugins on user's demand. And the best part is that it can be the same desktop plugin desktop part of the plugin, the part that you see in the UI. But it could be potentially, potentially hundreds and even dozens of different hardware devices. But currently we support Android, iOS, React Native, C++, and JavaScript, meaning Node.js or web. So in this case, let's imagine that we have Android, iOS, and React Native devices. And all of them could use the same UI part in Flipper. And Flipper ships quite a few plugins out of the box. In open source, have I mentioned that Flipper open source? Yeah, Flipper is open source, and lots of Flipper plugins are open source. For instance, the logs plugins that we saw before, that fetches the logs from the device, or CPU utilization plugin. And you can see the links on the screen, and also later you'll be able to get the slides and go to these links if you want to examine the code of these plugins. And I mentioned the support of various operating systems and even platforms, hardware platforms on purpose. The best part of Flipper is that the most complex part of the plugin is usually the UI part of the plugin. It usually has the most logic, and the device part of the plugin is usually fairly primitive. For instance, let's take a look at our navigation plugin that kind of commands the device to go to a certain screen. And this is, well, without all the boilerplate, this is, in essence, the implementation for our navigation plugin for iOS. As you can see, it's pretty straightforward. Myself, I'm not an iOS developer, but with a certain degree of confidence, I can read what happens here. Well, basically, we receive a message from Flipper, and then we tell the device to go somewhere. But that's only half of the story. Flipper also starts a WebSocket server that accepts connections from the applications on the devices. And, well, we can see here that, say we start different Facebook, Instagram, and WhatsApp applications on our devices, and then we display these applications nicely in the UI. And when Flipper discovers these applications, when they connect to this WebSocket server, Flipper creates a message bus between the UI part of the plugin and the device part of the plugin. And once this message bus is created, the devices are discovered, Flipper also can start custom plugins for every application on demand. And we can see that each plugin once again has two different parts. One part lives in the UI, and it's usually the most complex part. Another part lives on the device, well, in fact, inside of the app itself, and it just kind of syncs the data from the device or from the application to the desktop part to display it nicely in the UI, or maybe to interpret some commands and to do something on Flipper's demand. And once these applications start, once the plugins start, once the message bus starts, these plugins can start exchanging messages, doing all kinds of crazy stuff. Flipper doesn't impose any restrictions on what plugins can do. Well, we probably have some, but we try to keep the restrictions very, very small. We try to keep them to some minimum. So you can use this message bus in any way you want. And this is where you can let your imagination run free and wild. Sky's the limit here. For instance, you can use this message bus to peek into the application state. And if this conference was live, if I was live on stage, probably at this point, I would ask you to raise your hand if you ever debugged your application using console log. here I am. I'm a big fan of console log, but what if you could have a live representation of your state right on your desktop, right in Flipper in the UI, updating live, and you no longer need console log to dump the state of your application somewhere. It's there for you, and it's totally customized for your, say, React Native application. You can expect the application layout or tell your application to go to a specific screen, just like what we saw in the navigation plugin. You can simulate hardware signals. For instance, I have this wristband with me. It's not developed by Meta, I think it's Xiaomi, but it doesn't really matter. Say you develop a new wristband and the hardware is still in prototype, but you already negotiated the protocol, you know what messages are going to be there, and you want your developers to start developing, start creating an Android application, for instance. With Flipper, you could simulate hardware signals arriving into your application, and therefore you could unblock your mobile developers and let them create the application without depending on the real piece of hardware. How cool is it? You can also command your device or application to do pretty much anything. Don't let my limited fantasy set the borders for you here. Whew. On to the next part, how Flipper changes and why we're moving away from the Electron monolith. Let's review Flipper's architecture. Basically, we have two different parts. We have Flipper state, where we do device discovery, where we create this message bus, start the WebSocket server, and we have the UI, Flipper UI. And for a long time, it's been an Electron monolith, meaning that we had Node.js process, Node.js part, doing this device discovery and message bus business, and we had a web view with our React application displaying the UI. And we also had some Electron magic that allowed them to communicate somehow. And this setup worked quite nicely for a long time, but it kind of fails to provide necessary utilities in certain scenarios. For instance, imagine that you run your simulator not locally on your laptop, but somewhere far away, somewhere there in the cloud. How would you connect Flipper to your simulator then? Well, one of the ideas that you could tunnel your ports from your IDB, ADB, whatever, using SSH or something like that. Yeah, that could work, and that's actually what we've been doing for quite a while. So yeah, it totally works in real world. But then, what if you don't really want to develop using your laptop, at least not directly? What if you want to have some sort of remote developer environment somewhere in the same or different cloud? What if you want to exchange laptops, or maybe jump from a laptop to your desktop, or for any other reason, maybe your repo is so huge you don't really want to check it out every time. You want to have it checked out for you somewhere in the cloud, and you just want to connect to your cloud machine. How would you use Flipper then? Specifically, how would you kind of relay Flipper UI to your laptop? Well, yeah, there's a way. RDP, I'm looking at you. But this is actually would be a moment for me to ask yet another question to the audience. How many of you like using RDP. Yeah, probably there wouldn't be too many hands. For instance, maybe I'm just lazy to figure it out properly, but I've never been a huge fan of RDP. It's always been laggy for me for some reason. So, and I think that lots of people share my feeling here. But this is not even the end of our problems. What if you want to automate something? What if you want another program to interact with Flipper? Then how would you force your script, your program to talk to Flipper? How would Flipper understand these commands? And how would Flipper talk to the device in the end? Yes, some parts of this chain, they're solved. For instance, Flipper talking to the cloud, but the other parts are not. And to solve this, over the last year, we've been trying to split Flipper kind of in half. We've been trying to create a separate Flipper UI, which can be hosted independently and at least run independently. And Flipper server that would contain that stateful part with server, with device discovery, with the message bus, and etc. and etc. And this setup, where we have Flipper UI independent of Flipper server, could potentially solve all these scenarios. We could run Flipper UI on the script side, and then it could talk somehow to Flipper server. We'll cover how exactly later. The same setup also works quite nicely in the remote developer environment setup. We could run Flipper UI on our developer's laptop, and then it would connect to the remote machine and talk to Flipper server there. And also this way we could potentially integrate Flipper UI in any kind of application that supports web using our favorite iframes. Yay! So the current setup looks like this. We have a dedicated Node.js server which does the device discovery, does this message bus business, and we have Flipper UI, which is now a standalone React application which runs in our browsers, and they can talk via WebSockets. And you could notice that the previous setup, it didn't quite solve all of the problems. It was kind of weird that we integrated Flipper UI with our script, right? I mean, do we expect our script to push the buttons in the UI? Absolutely not. That's where the API part comes into play. Let's review again our high-level Flipper architecture. So once again, we have Flipper server, which is Node.js process, doing device discovery, message bus. We have mobile applications, and we have Flipper UI, which is a React application running in a browser. And you could notice that the desktop part of the plugin, it's displayed inside of that UI, and that's not a mistake. It's done on purpose. For historical reasons, we've been hosting a plugin state inside of the UI. So I'd even say that our UI has more state than our Flipper server. And that's a huge problem, because now when we introduce headless clients, when we introduce APIs, it means that our headless clients have to somehow run these plugins and maintain their state. Potentially, we could recreate all this logic in different languages, but then how would we run plugins? We could well, maybe we could start spin up different JavaScript machines, somehow do some sort of IPC mumbo jumbo to talk to these JavaScript-based plugins from some other languages. Whew. Yeah, my head is spinning just from describing this setup. Alternatively, we could force all of our headless clients to be Node.js processes. Then they would be able to use the same code that we use in our React applications, but the problem here is with Node.js. That would put a severe restriction on how Flipper clients could be implemented. After all, not everyone loves JavaScript. Alternatively, we could host plugins on Flipper server. The idea here is that most of the modern plugins, well actually all of the modern plugins, they are split in two parts, logic and view. And this logic part of the plugin, it exposes some sort of API. And usually this API is asynchronous. And usually, once again usually, parameters and the result of these API calls, they are serializable. Do you see where I'm going? Yeah, RPC. So what we did is we created so-called Flipper server companion that shares the code between itself and our Flipper UI, the code that manages the plugins and runs the plugins. And now that Flipper server companion, it exposes an RPC-like interface or WebSockets to our headless clients and runs the plugins, allowing these headless clients to send commands over this RPC to the plugins hosted on Flipper server side. Don't worry, we'll take a closer look at this in a bit. Let's get back to our Flipper tic-tac-toe plugin, which might be a perfect example of decapitating one of Flipper plugins that used to run solely in the UI. By the way, this plugin is also open source, and you can see the link on the bottom of your screen. And let's go over the source code of this plugin. So this part is our logic part, where we create the state of this plugin. There will be a three-dimensional grid to display on the screen, and we expose some API calls: send update, make move, reset. We do some magic when the plugin connects, and we return back the API calls. Let's go over each one of these API calls individually. For instance, this make move call. What it does, it just verifies that this is the right player, blah, 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 blah. Essentially, what it does, it computes the next state of the plugin and sends this state to the device. So whenever player in the UI clicks on the button making a move, a new state is going to be calculated and sent over the wire. Send update, as simple as that. Just get the state, serialize it under the hood, and send this data over to the mobile device. And on connect magic, what happens here is that we create a bunch of message handlers. So whenever we receive a next move message from the device, we make this move, calculating the state. Whenever we receive a get state message, we just send the state to the device. And initially, when the plugin connects, when the device connects, we send the initial state to the device. The view part is pretty straightforward. We just kind of input this API using use plugin hook, and then we just iterate over the existing cells to create this two-dimensional grid to display our buttons to click. And the new part here is this API function, which kind of whitelists the API calls that we are allowed to use in headless context. You remember that I said that not all of the API calls could be serialized, only the asynchronous ones, right? So yes, this function is intended for this very purpose, to kind of blacklist the calls that cannot be used in headless context and maybe do something extra. Maybe you want to expose some sort of a different API or the why, who knows. We just wanted to give plugin developers as much freedom as possible. And in the end, this is what happens. When a headless client tries to use the API, on the client side, it might look like just making a call if it's JavaScript or any other language. But what happens under the hood is that we send a message, a JSON or WebSockets, and we are telling our Flipper server companion that this is plugin execute command, and this message has some sort of an ID, therefore it expects a response, and the data part of this JSON contains what API call should be called and the arguments for this API call. And whenever this API call executes on the Flipper server side, somewhere there, the response is once again serialized and sent back with the same ID and with the data from the API call. Whew! Demo time! Well, I have a confession. I'm not that cool to do real-life coding, so I pre-recorded a video for you. And in this video, I'm playing the game of tic-tac-toe using my UI, clicking some buttons, playing tic-tac-toe from my mobile phone with the desktop counterpart of the plugin. And now I'm doing the same very thing using our headless client, playing tic-tac-toe in my terminal. Yay, making some moves. There you go, there you go. Who is going to win? Me or me? Yeah, I like winning. Yay, I won, woo! The source code for this demo is going to be available on GitHub, and you're going to see a link later. So don't worry about that. If you're interested in playing with that, you'll be able to do so. Going back to our slides, I promised you to cover how we're using Flipper at Meta, right? So far, for Headless Flipper, we have two scenarios. We're working on next integrations, but so far we have two integrations working. The first one is our design verification procedure. When our designers create their amazing, mind-blowing design, we do what we can to implement it to the best of our abilities. And well, luckily for us, we have a design verification procedure when we submit a screenshot, and our designers can go back and verify that our implementation matches the intent. And currently, this is what happens. Developer can type a command in their terminal asking Flipper to take a screenshot on the device and to submit it to the cloud. So when a developer types this command, the CLI client sends a WebSocket message to Flipper Server Companion and starts our UI validation plugin. This plugin connects to the device and prompts the device to take a screenshot. Then this screenshot is transferred back to the device. Well, not to the device, to Flipper plugin. And then this screenshot is uploaded to the cloud. But from the developer's perspective, it looks like a single terminal command. Ooh, how cool is that? And the next one, in my view, is even cooler. We're exploring how we could integrate Flipper with our end-to-end tests. Say we have the following setup. We have a terminal from which a developer can start an end-to-end test suite. We have a web browser when this developer can see the result of the test suite execution. We have Jest running somewhere there in the cloud. Well, alternatively, it can run on developer's laptop, but who cares? Let's imagine that now it runs in the cloud. And in a totally different cloud, we have, well, this was Jest cloud, so this cloud is going to be device cloud, where we have all the simulators. And Jest runs some testing magic there. And at first, as the first stage, we've decided to allow developers to debug their end-to-end test suites with Flipper. Because say you have a very long test suite that does like a crazy amount of actions doing something on the device, but then something goes wrong. How do you really debug it? Do you watch a video? Do you try to imagine what happens there? What if you could have Flipper with Flipper server living next to your emulators in the cloud, and then you could see Flipper UI right in your browser inspecting the data from your simulator. But let's not even stop there. Say you have data from your Flipper server in Jest end-to-end test suites. Could you run any assertions on the state of the application? Do you remember that we have like dozens and even hundreds of plugins, of custom plugins for lots of applications that fetch some custom state from the application? Well, what if you could do snapshot testing with Flipper? Or what if you could do Flipper dumps and make Flipper save a lot of debugging information during your end-to-end test runs and then examine this information later? How cool would that be? That's something that is not implemented really right now at Meta, but if you decide to give it a try, give us a shout on Twitter. We would love to hear your story. Whew! This is almost the end. As promised, links to the Headless demo and the Headless tic-tac-toe client. Feel free to add us on Twitter and on GitHub. And feel free to reach out to me with any questions, once again on Twitter or on GitHub. This is legal stuff, so we don't get sued. Referencing the images that I used. The QR code leads to this slide deck for future references. It was a pleasure to meet you all. Thank you. And let's make the developer experience better together. Woo!
Yeah, let's do that. Flipper is such a powerful tool, and answering the question from the presentation, I do still use the console log. Yeah, that was our first part of today's React Native conference. We will have a 15-minute break right now, so go grab some coffee and be sure to be back in 15 minutes. We will have another great talks for you. So see you in 15.
This conference is brought to you by CodeStack, React and React Native development experts.
Hello.
Whoa. Welcome back after the break. I hope you are rested. Let me introduce our next speaker about localizing React Native apps from start to end. It is Vojtech Novak.
All right, hello everyone, back from the break. I'm excited to be here. My name is Vojta, and I'll be talking about localizing React Native apps. Firstly, something about me. You can find me on Twitter and on GitHub at Vojnovak. I'm a maintainer of a few React Native related libraries, such as React Native Google Sign-In, the Datetime Picker repo, Document Picker, and then also, most recently, I have released React Native Theme Control, where I'm running a bit of an experiment because it's currently for my GitHub sponsors only. Until, I'm going to open source it when I reach my sponsorship goal. So that's an experiment. And I want to start off this talk by kind of giving you a promise that, regardless of whether you are a starting developer or maybe a senior developer, I really hope that, you will learn something new today and take something away. And so in this talk, I'll be talking about, I'll be doing a quick comparison of some libraries that you can use to localize your apps. I'll also be talking about some mistakes that happen in the translation process and how to prevent them, what you should or maybe should not do to help translators deliver the best result possible. And I want to shed some light on what tools the translators themselves are using, because I think it's important for us also to understand how they work in order for us to do our job better. All right, you might think, what's the deal? I mean, we're translating strings and localizing apps like every day. That's that's kind of a solved problem, no? And, well, maybe not necessarily. As I was preparing for this talk, I was collecting some screenshots of mistakes that I have seen that happened to someone else or maybe to me. And this is the first example from the PayPal website. You'll see that at the top arrow, there's this blue outline. That's a button, actually, and it has no text, no label whatsoever. And then at the bottom, the arrow is pointing at a button which is localized into Czech, which is my first language. But the rest of the UI is in English. So you see that something is in Czech, something is in English, something is missing completely. And it's just not the kind of experience that you would expect. Another example is, you're trying to localize some string and then maybe call some string method on it. But the string is not there, and it ends up with a runtime crash. This is probably the worst thing that can happen to you, and I don't even know how it happened to me, but in theory, obviously, it apparently can happen. This is another example from the VS Code website, where I ran it in the browser, and there was this alert that you see in the middle, and you see that some of the labels have not resolved to an actual English word or an English sentence. The only button there is the cancel button, which is an actual, the correct translation. But the rest of it are just like translation keys or translation identifiers. And this is still much better than not having any translation at all. But it's, not quite there yet. And so I just got curious about the topic, and I also even more than 2 years ago already, I asked on Twitter what folks were using for localizing stuff. I got some interesting responses, and in the end, here I am. All right, quickly about some of the localization libraries, and there's a bunch of them. So I had to, make some choice, and I plotted on this npm downloads graph the 4 libraries that kind of came to my mind. From the top, the most popular one is React I18 Next. The next one is React Intel. And at the bottom, the blue line is a Lingui library, which is kind of nice, I think. And all the way at the bottom is FBT, which is a library from Facebook, actually. So these two are like floating under the radar, really. But I needed to pick some libraries for the comparison that I wanted to make, so I picked the most popular and the least popular in terms of number of downloads, which is i18next and FBT. And the demo is available, or will be available at this URL. And the demo app looks like this. It's just a very simple app that I have built just to play around. And so at the top, it's divided into two parts. They're both the same. At the top, the UI is built using FBT, and at the bottom, the UI is built using i18next. So let's have a look at some code, and this is the FBT component. I'll start, slowly from the top. So at the beginning, there's a string which just contains the current date formatted as time with hours and minutes. So it might be, for example, 10 a.m. a string, and then I have a constant number of people watching. Oh, actually, let me go back here. I just want to point out what use cases I'm covering here. So, at the top, the first sentence is just a very simple static string. And the second one has a number inside of the sentence. So this sentence is here to showcase pluralization support. The third sentence has the date at the end of the sentence. So this is here to show sort of parameter or variable inside of the translation. And the fourth sentence at the bottom is here to showcase sort of a complex sentence, let's say, a complex sentence where parts of the sentence are styled differently. And yeah, sorry for the bad example. It was just like the first example that came up to my mind. Metastock is actually down today, so sorry. But these are the most common scenarios that you will probably encounter. And so, looking at the code, the important part is the text label. The Welcome to React Native EU label. And you see that the way FBT works is that it just wraps the text inside of the FBT component, and you pass the description prop, which is mandatory actually. And the description is there for the translator to give them more context about what this string is, and it helps the translator translating it properly. Next sentence was the one with plurals. Now, if you're not familiar with plurals, what I'm talking about is, in languages, when you have some quantities or numbers in sentences, the sentence can take sort of different shape. In English, there are two forms. There's singular and plural. Like you have one car, you have two cars, and those are the two forms that are there. But other languages have different numbers of forms. For example, my language has like 4 or 5. Or for example, Japanese doesn't have any. They just don't have plural forms. They have just like one. And so in the code, we somehow have to account for this. And this is the way that FBT handles it. Again, you start with the FBT component, and you sort of plug in the plural component to express the number using the component. And so this is going to, based on the variable, it's going to render either, like one of these sentences. Let's say, for example, you have one person watching, or you have 2 people watching, where, well, there's more, luckily. All right, the next example. Yeah, let's make some space. Next example was with the parameter at the the date at the end of the sentence. And again, this is the way FBT handles it. There's a FBT param component, and inside, as a child of this component, you pass the actual value of the variable. And then finally, the complex sentences, as I have called it. Here I'm making use of nesting text components in React Native. If you're not familiar with how it works, basically you can nest text components and give a variable styling to parts of the sentence, and this is what it's going to look like in the end. And the result is then wrapped by the FBT component again. And the really important and crucial part here is that you wrap the entire sentence with the FBT component, because then it's going to extract the entire sentence from the sources, and it's going to keep it as one piece, and then the translator can translate it properly. Whereas if you were to break it down or break it up into different pieces, you will not get a quality translation. All right, just quickly, this is what so FBT runs through your code and extracts the strings out of it. This is what this is what part of the resulting JSON file looks like. It's kind of a proprietary format, I guess, of Facebook that they have developed to like serve their purpose. And next is the I18 Next example. Again, the beginning is kind of the same thing. So let's jump straight to the interesting part, which is the text label again. So here I'm calling the T function, and I'm passing two parameters. The first one is the message ID, and the second is the default value. So I18X is putting more emphasis sort of on using these like handwritten, let's say, translation IDs, whereas FBT is generating these IDs. The next example is the plural, and here you'll notice it looks quite a bit different from FBT. And again, depending on if it's one person or some different number of people watching, it's going to render either one of those translations. But you'll see here that there's, like, I guess two differences. One is that the sentences here are like written out in their entirety. So you have the entire sentence sort of written twice, and there's some overlap. There's some duplication between the two sentences. That's the first observation. And the second observation is that I18X is using this convention of their own that they use double curly braces to wrap the count placeholder, which will be replaced by the actual variable at the runtime. Again, this is the sentence with the time at the end, so using a variable, and this time again we're using the double curly braces convention sort of that I18X has. And just quickly, this is the JSON file that I18X is going to spit out when you extract the strings. This is what it's going to look like by default, but I18X supports also other formats. To wrap this up quickly, the comparison, I would say, FBT, the pros, what I like about it is that the source code of your app is kind of easily searchable. Just by Command F, you can find the pieces of strings that you're looking for. Whereas, if you're using I18X and you have the translation keys, which are some identifiers, you will not find the translation or the strings themselves in the sources. Also, what's interesting about FBT is the support for commands for translators, and as I said before, they are required. Also, FBT has a smaller bundle size, but there are some cons. As we have seen before, the community is much smaller. It requires Babel to extract the sentences out of the strings, so maybe if you're using SWC, you will not be able to use it. And Facebook has developed their own file format that serves their needs. And as I was looking at different translation tools, I think probably only Crowden supports FBT file format. Otherwise, if you send it to some translator, they will probably say like, "Oh, I've never seen this before." I18X, has sort of the opposite. Large community, many plugins. It's been around for probably a decade or so. So they probably covered all sorts of scenarios that they ran into. And it's also unopinionated, so you can use whatever tooling you want. The cons that I have, personally picked is that some of the APIs kind of feel unsafe with these double curly braces. If you make a mistake there, the translations are probably not going to, they're not going to render correctly. And also, it has a larger bundle size. I will not be able to say which one is better. I just can't. It really depends on your use cases. But these were just some, my personal observations. So next, about some translation services. Sometimes they're also called CAT tools, which unfortunately has nothing to do with cats. CAT stands for computer-aided translation. And my only point here is that don't use email or spreadsheets or some other, I don't know, ways that you're communicating with your translators, because these tools are cloud tools. They're developer-friendly. They have CLIs, APIs, GitHub integrations. They allow you to hire translators. They're just going to make the process much smoother for you. So, just to mention a few, there's Crowdin, Phrase, or Localize, which is by the creators of i18next. So it's definitely going to work well together. All right. As I promised, I wanted to talk about how translators work. So let's have a look at some of the things inside of the translator's toolbox. And the first one I'm going to mention is translation memory. Translation memory is essentially a database of all the translations that your agency or translator have created. This doesn't sound terribly useful at first, but trust me that it is. Imagine, for example, that you have a website which is already up and running, and then your company decides to create a mobile app for the same service. And it doesn't matter what technology they're using. Basically, you're going to build out the app, and some of the strings inside of the app are going to be probably very similar, or maybe even the same as in the web app. And so as you translate these new strings, and you use the translation memory, because many are going to be the same, you're going to get them translated from the translation memory just like this, zero effort. Next tool is machine translation. I think this is kind of obvious because machine translation has become much more mature and viable in the past few years. And oftentimes translators use it to sort of get a quick translation for a string, and then maybe they look at some mistakes that need fixing and just polish the result of the machine translation. The next one is term-based, and so I'm going to explain this by an example. Imagine, you're Apple, the company Apple, and you have a bunch of strings, in your software, in your terms of service or whatever, where the word Apple is mentioned. And if you translate these strings, maybe using machine translation, chances are that the machine translation is going to translate the word Apple into the language, into the target language. But the word Apple here is not an apple, it's the name of a company. You don't want to translate it. So what you can do is create a term in a term base, and the term is going to be Apple, and you're going to flag it as a non-translatable term. And then whenever the translator, by mistake, translates the word Apple, it's going to scream at him and be like, hey, you probably don't want to translate this word. And this is related to quality assurance. Quality assurance is going to scream at you. This is a bad translation. But quality assurance can also, catch typos, or maybe if you have parameter in the source sentence and you missed it in the target sentence, it's going to also flag, these mistakes. There are workflow steps that you can use. And as an example, there might be pre-translation from translation memory or from a machine translation. Then maybe you'll have an actual human being edit the strings, fix some mistakes. And maybe the last step of the workflow steps can be you as a client having a look at the translations and be like, yeah, this is good job. Approve it. And the last tool I want to mention, which kind of integrates all of these, is a translation editor, which is kind of, can look like this, and it's kind of an IDE that the translators use. And there's really some interesting, comparisons maybe with the IDEs that we are using. If you look at the red rectangles, there's autocomplete. So translators can use autocomplete. It's kind of like IntelliSense maybe. There's also machine translation, which maybe can be like GitHub Copilot for translators. And there's also the quality assurance here, which maybe can be compared with ESLint. And the last thing I highlighted here is screenshot management, which I will talk about later. So what about some of the common mistakes that happen? This is the first one, concatenating messages. I have a screenshot from booking.com just to point out that it can happen really to everyone. I don't want to go into the details of the sentence, but it's sufficient to say that the sentence is not completely correct. And I have a hypothesis about how it was created. They had, error object and something was missing, and they just concatenate these things together, like location is missing or date is missing. But this might work in some languages. It might work in English, but it's very, very likely that it's not going to work in other languages. So, and I think this approach stems from us developers hating duplication. We try to avoid it at all costs, and we often follow this principle of don't repeat yourself. But with translations, it is oftentimes the case that you actually want to be wet. You actually want to write everything twice rather than not repeating yourself. And I should make a note here, because actually FBT has a special component to avoid some of these duplications. But so having some abstraction to avoid duplication, there's a cost of having the abstraction. So personally, I feel like writing out some of the strings 2 times is actually not a big deal if what you get is a quality translation in the end. So the next mistake is like missing translations. And I don't know how this happened. This was a screenshot from a website. But for example, i18x has TypeScript support, so it can flag if you're trying to reference missing keys. There's always fallbacks, so you can fall back maybe to the translation key, like we saw in the Visual Studio Code website. If you're working with some complex translations, you can always write component tests. And finally, I want to say, like completely missing translations probably will not happen in React Native. This is screenshots from the web, where I feel like the story is probably more complex. You can fetch translation strings at the runtime and so on. Whereas in React Native, you will probably bundle all the translations together with your app at the build time. Where I just want to make one note, like if you're bundling the translations with your React Native app, it's going to work okay if you have, let's say, 5 or 6 translations. But maybe if you're a big company and you have 100 translation files, bundling them inside of JavaScript is probably not going to work well. All right, missing message context. And I've been talking about context a lot, and I will still be talking about context. But here, imagine for a second that you are a translator, and you're translating from English to Czech, and you're translating the word German. It's just one word, right? It can be too difficult. But maybe you don't know Czech, so you call me up because I'm Czech, and you ask me, hey, what's the translation here? And I'm going to say, well, I don't know. It really depends. It depends on the context. And so here, to give an answer, maybe German is a noun, in which case it might be either one of these translations. But maybe the word German here is an adjective, in which case it might be one of these 3 words. So you have at least 6 possible translations for one word. And it all depends on context. And there are different ways to add context. This is on the web. This is a tool this is in-context translation tool from phrase in this example, where the translator can run the website and translate, like select the strings and translate them in place using this sort of iframe that phrase is providing. And they will see all the strings in context, and they can translate them right in place, which is that's the best way to translate stuff for the translator. But this is probably not going to work for React Native. For React Native, I think there's a different way, and which is adding context at design time. And sorry for the poor screenshot, but the point here is that the first person probably working on the experience of your app is a designer. And designer goes in Figma, and they design the components there. And already at that time, they can see that maybe some string is okay in English, but it's too long in German, and they can redesign the experience. When they connect Figma with machine translation, they can get quick feedback on the design. And already at that time, they can define the translation keys, and they can also upload screenshots of their designs from Figma inside of these translation tools. And then when the translator comes to do their job, they have the necessary context. So I think this is a pretty cool tooling. And sort of the overarching message that I want to send here is having quality strings, or having quality in general implies trustworthiness. And you probably don't want your users to not understand your app, because you're going to get bad reviews, and ultimately it's going to affect your business as well. All right, finally, well, let's also talk about localizing native stuff, because after all, we're doing native apps. On iOS, this is kind of the fastest way to get or set the localization of your app. And personally, I recommend this is going to set it sort of in these settings, and I recommend taking this place as the source of truth for all your localizations, because otherwise you might end up with a broken UI like over here, because some parts of the app are controlled and rendered by you. So you see some parts of the app are in English, but there's also parts of the app that you do not control, such as the context menu on the text input, which here is in Chinese. So you have here, in this case, you have sort of two sources of truth for the translation, and you don't want that. So in iOS, if you want to add support for locales, you go to the project settings, and you can easily add a locale there, and then there's localizable strings file where you can add your translations. And then if you want to change the language, well, you go to the settings and you select the app, and in there you change the language. And by the way, this is not going to work on an emulator, so you have to do it on device. On Android, for a long time there was no notion of changing the language of your app. It would just take the active locale from the system settings. But as of Android 13, this is fresh out of the oven, there's going to be this feature per app language preference, where it's going to allow you, same as in iOS, to change the active language of the app. All right, some final notes. React Native Localize or Expo Localization are some cool libraries that you can use to localize your apps. They give you necessary information for that. Intel APIs is a big topic in React Native, and as of React Native version 70 or 070, Intel APIs are going to be available in Hermes, on Android, and on iOS as well. Although I have to say that you might still have to use polyfills for some features, because on Android the support for Intel APIs is kind of dependent on the runtime version of the system. There are some cool plugins for IDEs. There are also plugins for ESLint. I also want to mention the FBT talk given by the developers from Facebook. And I think here I really just barely scratched the surface. The localization topic is kind of much more deeper. If you ask around, you'll see different people do it differently, and they have success and maybe less success. So I think it's a really interesting topic, and I encourage you to talk to your fellow developers about how they're doing it. And then maybe finally, one last thing. If you're designing for an international experience, you also have to keep in mind using correct fonts. And in this case, in languages such as mine, which have weird characters, weird characters might render differently from the rest of the characters. So if anyone from Google is watching, I just want to let you know that the Czech characters don't look right in Chrome. All right, this is it from me. I hope you learned something new, and see you next time.
Whoa. Thank you, Wojtek. Such a detailed overview. I think it's good to see the other side of translation process, to look at the tools that the translator use. Awesome. For our next talk from Formidable Labs about visual regression testing in React Native, it is Rob Walker.
Hi, my name's Rob Walker. My pronouns are he, him, and I am a senior software engineer at Formidable. My talk today is about visual regression testing in React Native. If you'd rather watch these slides on your own device, you can access them now at bit.ly/rn-vrt. Now, to start, I'd love for you to join me on a little story. Imagine you're building an app, perhaps an e-commerce app, and that app's got a shopping cart with a checkout button and the total price, as you'd expect. And one day you're working on a separate part of the app, perhaps changing the styling on the login screen. And you decide that you should go and do a search and replace, swap the min width for the width, and that works great. Your login screen looks fine, login works, you create a PR, your tests run, everything passes, nobody spots the issue. So let's ship the app. And as soon as it gets in the hand of your users, you start getting loads of negative reviews on the app stores. And when you go to see why, you discover, obviously, search and replace was a little bit too broad, and you've completely screwed up your shopping cart screen, leaving some very confused users. And this is where visual regression testing comes in. So with visual regression testing, the visual aspect covers everything that your user can see in the app. So the layouts, the styles, the colors, the images, even the contents of the image itself, all the text that you can see, and the flows, by which I mean kind of multi-stage processes, perhaps an onboarding flow or a full checkout flow. And the regression testing is trying to catch any accidental or unexpected changes, such as the one in our example, and trying to catch as well any kind of broken flows or processes in the app where maybe individual screens are fine, but when you try to actually use them, the end result isn't quite what you expect. So visual regression testing is normally implemented by taking screenshots of the app and comparing those screenshots. So your baseline screenshot, you would have that normally committed into version control, and that is a known good state of the app. And then every time you make some changes in your app, you would rerun all the screenshots and compare them to create a diff. And if there's some differences, then that could indicate that something has gone wrong and your tests would fail. If the screenshots match, then that's a pass and nothing unexpected has happened. So how do we prevent these kinds of issues today? More often than not, it's through lots of manual testing. And manual testing is obviously really important. You probably do it every time you're making a change to the app already. And it's great for exploratory testing. So you might make a number of changes to an app and then spend some time just playing with your app, checking out some key features to make sure nothing has unexpectedly changed. And it's really flexible, and you can also outsource it. So as a developer, it's quite often good to have somebody else test your work, and they might find some issues that you've not considered. And you can outsource it to those kind of other developers, or there's third-party companies that can dedicate people to spend time testing your app for you. But obviously there's a few issues. It's very easy to miss things, and it's very time-consuming because it's a manual process. And it's hard to catch small changes. So if you're testing an app, you might not spot that an image has changed or the styles are different in some way if you didn't know exactly what should have been there to start with. You can use just snapshot tests. So this is where you serialize the output of a component. So you might serialize the JSX, perhaps the style object, and then you can compare the serialized output after a change with like the known good baseline and see if anything unexpected has happened. This is quite fast to implement, and it's very fast to run, and you can run it on CI, so there's nothing manual required to actually run the tests. But these tests only test in isolation, so you might do a snapshot test of your button component, a snapshot test of the contents of a list view, but you're not testing how those things are working when they're combined in different ways on the actual screen for a user. And it doesn't test flow, so you can't test like every step of an onboarding flow to check that it actually works end to end. And often you're only comparing the JSX or maybe the styles. You're not comparing like the contents of the images and how it looks on the screen. And then third, probably the rarest form, is visual regression tests. So this tests the entire UI, everything that's actually rendered to the screen. You can check multiple stage flows. So you're actually going through, say, a login process on the phone, screenshotting it as you go. You can check that you do get to the end state. And you can run it on CI. So because you can use an emulator or a simulator in a CI environment, you can run it there, removing the need to kind of manually run your tests. However, it can be more difficult to set up. It's slower to run on CI because you're having to install and boot and run an emulator. And they can be potentially flaky. So with our example earlier, it's such an obvious issue that it's likely that any type of testing there would have caught it. A tester would have seen this issue. Snapshot tests, if you were testing the styles, would have indicated that the style had changed in this component. And visual regression tests, if you had a screenshot of the shopping cart screen, that would have indicated it had changed. But how about a more subtle change? So here you can see a shopping cart screen, and the user is scrolling down the screen, and at the end of a scroll view, there's an Apple Pay button, a PayPal button, and fixed beneath the scroll view is a normal checkout button. When the user releases their scroll after over-scrolling, it kind of settles where one of the buttons is partly obscured by the checkout button. Now, with manual testing, I think it's quite likely that if someone had just been testing this flow quickly, they could easily have missed that. They might never have scrolled to the bottom of the scroll view. They might have scrolled just enough to hit the Apple Pay button. Maybe they scrolled all the way, but didn't realize that like the over scroll, and then when it bounced back, it was obscuring the button. So it would be quite easy to miss. I think snapshot tests, you could also easily have missed this issue. Because if you were serializing the button component, nothing there has changed. If you were serializing and comparing the contents of the scroll view, nothing there's changed. It's only how the scroll view and the button are interacting relative to each other that creates this problem. Visual regression tests, if you had taken a screenshot after scrolling the scroll view, then there's a visual differences when you compare a screenshot from before this issue to after this issue. So that would have indicated that something maybe has gone wrong on the screen. So how can we implement some visual regression tests today? Well, I'm going to show you a demo using React Native OWL, which is a visual regression testing library for React Native. And the aim of React Native OWL is to make it as easy as possible to get started with visual regression tests. To achieve that, it has a few components. So there's a really small CLI that you use to build and run your app for your tests. There's a custom jest matcher, which is used to compare the screenshots with the baseline and the latest screenshots, and kind of control whether the test fails or passes based on that. There's an interaction API, which allows your tests to interact with the app in the simulator. So you can do things like press on buttons, scrollables, enter text into inputs. And then there's a report generator. So when your tests pass or fail, you want to be able to find out easily like what was wrong if there was an issue. So you can easily go and fix that. So like most things nowadays, it's fairly easy to install. You can just yarn add React Native OWL. And then you add a small config file. So this example has a configuration for both running your visual regression tests on Android and iOS. And for this example that I'll show in a minute, we're using Infinite Red's Ignite Bootstrap to kind of get a demo app working really quickly. And then you write your jest tests like normal. So this example test is essentially going to press on a button where the test ID matches next screen button. Then it's going to take a screenshot of the resulting rendered screen and call that screenshot demo screen. And then it's going to expect that the screenshot you've taken matches the baseline screenshot that's previously been taken using the same kind of name for the ID. And if there's no differences, it passes, great. But if there's an issue, it will fail. Now this is the whole demo test that I'm going to show you running in a minute. It's probably quite hard to read, but essentially it's going to take a screenshot of the welcome screen, click a button to get to another screen, a further button to get to like a list view screen, taking screenshots along the way, and then it's going to scroll to the end of the list view and take a further screenshot. Before you can run the tests, you have to use the React Native OWL's build command so that it builds the app, but it also builds it in a way in which React Native OWL can interact with the app while it's running. And then you run test. In this example, we're building and testing for iOS, but it works just the same for Android. So it's just run our test there. As you can see, it's fairly quick once the app's launched. And if you're pretty eagle-eyed, you'll see in the output that it's actually indicating that it's creating the baseline screenshots as it goes. So this is the first time we're running the tests. If we see some of the output there, you can see it's actually creating the baselines. And once you've checked that the baseline screenshots look fine, you're happy with them, then those you commit into version history. And that's what your future tests will use to compare against. And you can look at those easily. They're just stored in like a baseline iOS directory. So there's the 4 screenshots we took. You can see the welcome screen one there. If you now run the tests again, this time you get a different set of screenshots. We already had baseline, so now we go and create the latest screenshots. And because we've not changed anything in the app, as you would expect, there's no differences. So in this case, the baseline and the latest will actually be an identical set of images. And it also generates the report. So because everything is passed, our report just shows the 4 screenshots that all pass tests. So we can check that kind of the test coverage is pretty good. If anything isn't included in these screenshots, then you want to go back and maybe update your tests to get a screenshot that covers the thing that you're interested in. But in our case, we're happy. So now we're going to go and actually change something in the app. The Bootstrap app came with this image on the left. We want to swap that out with the Formidable logo on the right to get something that looks more like this. So after making that change, if we run the tests now, as you would expect, one of the tests will fail. The welcome screen where the image is shown will now fail. And you can see it's pretty clear that the screenshot didn't match. But you can't really learn that much more about why it hasn't matched here. But if we go and look in the files again, you'll see there's now, in the diff folder, we have an image that was generated that will help us debug the issue if we're not sure why it doesn't match. And the image looks something like this. So you can just about make out all of the parts of the latest and the baseline that match are kind of grayed out, so you can just about make it out, but only just. But everything that changed is really clearly highlighted in red. So if this was an unexpected change, it would be really easy to see exactly what caused the test failure. And if we look at the report, you can see even more clearly, we see the baseline and the latest and the diff. So that will make it really clear what's changed. Now, this was quite a big, obvious change, but it works great for really small things too. So if you accidentally, changed some of your text in the app, so in this case we're going to swap the exclamation mark for the full stop, make a really small change, it works just as efficiently. After we've built and run the tests, then you'll get a test failure. Now, it's kind of not that clear what's changed because it is so kind of minute, but if you kind of take an eagle-eyed look, you'll notice that it does actually still indicate exactly what's wrong. So something that a tester would never see, we can catch reliably with some visual regression tests. So going back to the image change, now we made this image change on purpose. So it's not unexpected, it's not a bug. We're happy to update our baseline images. Now we know this change exists, so that future tests are compared against like an updated baseline. And you can do that either by copy-pasting the files in the File Explorer, or you can just run the test again with an update flag, when it will just go and run through the test, but instead of creating the latest screenshots, it will just update all the baselines. And you can see here, that's happened. So we've now got a modified welcome screen baseline, which we can then go and commit that to version control. And now all of our future test runs will be based on the Formidable logo instead of the placeholder image that was there. Now, if we'd been using something like this when we did our find and replace kind of error earlier on, we could have prevented the app ever getting into the hands of users automatically. So once we had made that change, we'd have pushed it up to Git, maybe opened to PR. PR tests could have been run, including the visual regression tests, and we would have seen something like this in GitHub, completely blocking us from doing the merge and making it kind of obvious what the problem was when you started looking into it. Now, there's also a bonus feature that you get for free when you use something like this. So if you create a PR and you have to update your baseline images as part of that PR, because those new images form part of your pull request, then somebody reviewing your pull request will be able to see it directly in GitHub, the before image and the after image of your updated baselines. So for changes that have some new content or style changes, it's really easy for a reviewer, without even having to launch the app, to be able to see exactly what it looks like when it's running on your phone, both before and after, which should make it really easy to quickly approve or reject pull requests. Now, there are some other options. You can use Detox, which is for React Native, which is a really powerful testing library. Detox, you can take screenshots with, and if you can take screenshots, then you can set up some kind of image comparison, image diffing, similar to how React Native Au does, and you can implement visual regression tests that way. And on the web, you can also use something like Cypress, and Cypress has several visual regression testing extensions that, again, work in a very similar way, but for web-based React. Thank you very much for listening. I hope everybody has learned something about visual regression testing or React Native AU, and I'd love to hear any stories about how it goes if people want to give it a try. Again, these slides are available at bit.ly/rn-VRT if anyone would like to look back on them. Thank you very much.
Thank you, Rob. It's amazing to see new testing libraries coming into life every month. It's really important to test your applications. Please do that. Another talk, React Native at scale, how Microsoft is betting big on React Native to target billions of users. So from Microsoft, it is Steven, Shiven, and Slobo.
My name is Steven Moyes, and I'm a program manager on the React Native team at Microsoft. I'm so excited to be here and represent the React Native team. As it turns out, this is actually our 4th year participating in the React Native EU conference. This presentation will discuss how Microsoft is using React Native at scale to target billions of users across mobile and desktop. We hope that by the end of this talk, you'll learn a little bit about how Microsoft is using React Native and how you can leverage your React Native skills to also target even more users than ever before. Before we jump in, I'd like to introduce my co-presenters Slobo and Shiven. Slobo won't be joining us in person today, but he'll be sharing a demo a little bit later about Windows using React Native for Windows in Windows. And now I'm going to pass it over to Shiven to introduce himself.
Hey everyone, I'm Shiven and I'm a software engineer working on React Native for mobile.
Awesome. Thanks, Shiven. Now let's get started. Now, when we talk about scale, there are very few companies that are working on as many apps and products and services as Microsoft. On screen are a few of the Microsoft products that use React and React Native to reach users across both mobile and desktop. And this isn't even all of them. Today, we're going to look at a few specific examples and explore how the React Native platform is critical to the success of Microsoft. Now let's take a step back and look at the React Native platform itself. At ReactConf in 2021, the team at Meta described React Native's many platforms vision. They showed a slide similar to this. The many platforms vision spans iOS and Android, desktop and VR, web and native. At Microsoft, we share the many platforms vision, although we obviously have a soft spot for desktops. Now, when we talk about scale, we also know that JavaScript and TypeScript are 2 of the most commonly used languages by professional developers. We also know that React Native is one of the most popular cross-platform development frameworks, even beating out Flutter amongst professional developers, according to this year's Stack Overflow survey. We are blown away by the scale of this community and by the incredible things that you build, so it is critical to Microsoft that we help you bring these experiences to all of the users that Microsoft cares about. Now, in order to unlock the ability to bring your apps to both mobile and desktop, Microsoft is investing in improving all of these platforms, from iOS to Android, to Windows to macOS. Let's start with React Native for desktop, which includes both Windows and macOS. There are 2 critical things that I wanted to highlight on the desktop platforms. First, we strive to ensure that desktop is as capable and powerful as React Native Core. We work closely with the team at Meta to ensure that React Native for desktop keeps up with core releases, as well as following along with the latest innovations happening in core, such as Hermes by default and the new architecture. Secondly, React Native for desktop uses native components, meaning you get the latest look and feel by default. For example, when your React Native for Windows app runs on a Windows 11 machine, you get the latest styles and common controls by default. I just mentioned that React Native for desktop strives to keep up to date with RN Core. Here's a quick visualization showing how long it has taken to rev RNW to the latest version of core. Notice that over the last several releases, we've had a turnaround time of less than a week. We still have some work to do on the macOS platform, but the latest version is version 68 and was released on July 7th. Now I talked about a bunch of desktop platform investments, but let's see them in action. Windows 11 introduced the Your Microsoft Account page within the Operating System Settings app, which lets you manage your accounts, like your M365 account, your Xbox Gold account, etc. The settings team is using React Native to enable a fully native, high-fidelity experience in settings, while simultaneously enjoying the web-like developer inner loop. Now I'm going to pass it to my partner Slobo to show off these settings, show off the settings experience in action.
Windows chose React Native to improve developer experience and ship faster. Windows Settings app uses React Native on their Accounts page. The rest of the app is a native C++ XAML app. It has a near native performance and high fidelity. It behaves like a native app. Clicking on the button, we can launch a file explorer, or clicking any of these buttons here, we can open a browser. We can see here displayed billing information for Microsoft 365 subscription and also OneDrive information. Let's go to the browser onto accounts.microsoft.com and see our subscription information there. It looks familiar, similar to settings, where we see the billing information, but here we also see payment method information. Let's add that to our settings. First, what we need to do is enable debug mode for the settings app. Now I'm going to relaunch settings app, and it's loading the bundle from our dev box. It still looks the same. Let's go to the code and find where we need to make a change. So the feature flag here disables the payment method details. So we're going to enable it, and when I save it, the page should reload automatically. And here we have now payment method details.
Awesome. Thanks, Slobo. I wanted to quickly highlight two of the modules that the settings team used to create their experience, and so can you. These two modules let you call Windows-specific APIs to unlock the power of the native Windows SDK and the presentation layer so that you can supercharge your app on Windows. You can find more modules that work with Windows and macOS at reactnative.directory. This was just a taste of what the settings team built. If you want to learn more details about how and why the Windows settings app is using React Native, check out the blog at aka.ms/RNW settings blog. Shifting gears, I know Microsoft is investing across the breadth of React Native platforms, not just desktop. I'd like to pass the microphone over to my partner Shiven, who will explain how the Office team is using and improving upon RN for mobile.
Thanks, Stephen. Hello, everyone. So I'll be talking about another Microsoft product line used by millions across the world, and that is Office. We've invested heavily in React Native for building new experiences for Office over the last few years, especially on the Word, Excel, PowerPoint, and the Office mobile apps. And we're still growing. Here's just a few of the experiences running on Office applications, all powered by React Native. And you will find many of these experiences, not just on mobile, but across desktop as well. So as Stephen previously mentioned, React Native enables us to realize our many platforms vision. Let's take the example of the Office mobile app. So the Office mobile app allows you to open and edit Word, Excel, and PowerPoint documents all within the same app. This app has several millions of users and is available on both Android and iOS. As an example, one of the experiences we have very recently shipped to production in the last few months is the Feed tab, as we can see in this demo. So it basically gives you a personalized view of activity in your network, trending documents, and the ability to share documents with others. And this is a pure brownfield React Native application. And as you can see, it has seamless near native performance with native look and feel for each platform. React Native thus helps us bring out experiences that feel natural and tailored to each platform to millions of users. So in order to make the Office suite of applications super performant on each device, we realize we also need to make improvements to the underlying JavaScript hosting architecture. For example, we have the ability to choose the right JavaScript engine for the job based on time to interaction and resource requirements. Currently, we've switched over to Hermes from V8 for several of the features on mobile. We've also made changes to the way we host our experiences. We switched over to a single shared instance for long lifetime features that start on boot, and we kept a pay-for-play strategy for the others where the instance is created on demand. And these changes brought significant performance gains in runtime memory and bundle size. We're continuing to be flexible in the architectural choices that we make, where we decide on a feature-by-feature basis, and through our engagement with the community and the React Native ecosystem, adapting to further changes to the React Native architecture as it becomes more performant and easier for developers to build with. And finally, as you've seen by now, we've been using React Native for products across Microsoft and across platforms, but we're also as passionate about investing in the React Native community and giving back as we are in investing in our own products. One such investment we have made is improving developer tooling for React Native and creating a smoother developer experience. Please go check out our friend Adam Foxman's talk titled Changing React Native from Within to learn more about how Microsoft is making life better for all React Native developers. And with that, I'll pass it back to Stephen.
Awesome. Thanks, Shiven. Microsoft is using React Native to power experiences that reach billions of users across mobile and desktop. We hope that you're excited to use React Native to build at scale just like we are. As I mentioned before, this is actually our 4th year presenting at RNEU. If you'd like to learn more about React Native at Microsoft, I'd highly recommend checking out last year's presentations. We also have talks about how we work closely with Meta and a deep dive into how you can get started with React Native for desktop specifically. These talks and more can be found at aka.ms/reactnativevideos. It was our pleasure to speak with you about how Microsoft uses React Native at scale. We hope you're excited to get started. If you want to learn more, you can visit us at aka.ms/reactnative, and please check us out on Twitter at reactnativemsft. Thank you so much.
Thank you. Thank you, Microsoft. It gives me so much confidence and it adds credibility that we have 2 huge partners for React Native, Microsoft and Meta. I think it's so much better to have 2 instead of 1. For the next talk, Can't Touch This, different ways users interact with their mobile devices. From Aura, it's Eeva-Jonna Panula.
Have you ever thought, what would you do if you couldn't use your mobile device without touch? Or if you couldn't see what's going on the screen? For me, a couple of years ago, I would have thought that that's the end of the world and there is no other ways of interacting with mobile devices, that it would mean that I would be cut out completely from all these apps and services that I was using on my mobile phone. But today I know that there are actually multiple ways of interacting with mobile devices. So it wouldn't be the end of the world. And because there are so many ways of interacting with mobile devices, we as developers, we need to think about those ways, and we need to develop apps that work for other input methods than, for example, touch, which is the most used one for example, mobile phones. So today we are talking about different ways of using mobile devices or interacting with them. And we are also going to talk about what does this mean for a developer. So, a couple of practicalities before we start. If you'd like to follow along with the slides, you can find them from evis.codes/talks/can-touch-this. They're not really the slides you can see on the presentation, but they are a textual version of them. So you will get the same information, but not the same visuals, basically. So evis.codes, so eevis.codes/talks, TALKS/cant, CANT-TOUCH-THIS. So yeah, spelling is kind of hard thing, especially for a non-native speaker, but yeah, you can find the slides from there. Alright, and another thing before we actually get to the topic, a couple of words about myself. So I'm Eeva-Jonna, or Evis is the name that I actually recognize better, but my official name is Eeva-Jonna. And I'm accessibility specialist and senior software developer, and I come from Finland, and I work currently at Aura, so yes, the ring company. And my background is in web development, but I have a history with React Native. I have this habit of getting back to it once in a while, so I want to learn what's new in it and try these new things. So, not just web developer. And when I'm not coding, I love to explore the nature around here in Finland, because it's just so beautiful. I do that hiking and also kayaking, so I get to see more, I could say. And I'm a disabled person, but my main way of using mobile device, as you may have guessed from the intro, is by touch. But I actually have this reduced motion setting on, and I'm gonna talk a little bit more about that at later point of this talk. So yeah, all right, let's get to the main topic. And let's talk about different ways users can use mobile devices or interact with them. And the different methods we are talking about today are screen reader, physical keyboard, switch devices, voice recognition, and also zooming and or screen magnifying. So, what are screen readers? They are software applications that allow users to get feedback from the screen. And this feedback is provided either through speech or braille. And screen readers also make it possible to navigate a bit differently. So they provide more options for navigation, which make it easier for screen reader users to navigate. And most popular screen readers are TalkBack for Android and VoiceOver for iOS devices. And then there are others for desktops as well. But because we are talking about mobile devices here, I'm just going to mention these two. And you might wonder if you've ever heard about text-to-speech. Is this like the same or is there some differences? Well, there are differences. So text-to-speech, it has this similar possibility of listening to text on a screen. So you can select some text and listen to that, but it doesn't provide these navigation options. So it's just for listening text. But screen readers, they provide more navigation options. And who uses screen readers? Well, people who have trouble seeing or understanding the screen. And this can mean, for example, people with visual impairments, and also people with, for example, cognitive disabilities. And one thing I want to mention is dyslexia. So it might be sometimes easier to listen to what's on the screen than read it if you have dyslexia. So yeah, that's it about screen readers. Then there are physical keyboards. And when I talk about physical keyboards, yes, the same device that you are using probably with your computer. And there are people who prefer using physical keyboards instead of, well, touch, for example, or mouse if we were talking about computers. And examples of these types of people can be, for example, many people with motor disabilities, people who have tremors, so their fine motor control is not so precise, so it's easier to hit the enter, for example, instead of trying to hit that small touch target area on the screen when you have tremors. So there are different types of people who use, and some just prefer, some just like using keyboards for navigation. On computers, I use keyboard a lot to navigate because sometimes it's just faster. And these physical keyboards, as I mentioned, can be similar things that you use on your computer. So, well, would look the same. But there are also modified keyboards that might be in different shape or have less or more keys in it, or keyboard mimicking hardware. And now you might be thinking that, okay, so if there is so many different devices, how can we think about all of those? Well, these keyboards or modified keyboards or keyboard mimicking hardware, they are basically working just the same way. So they are responding to the same events. So you have to, you can test these with your own keyboard. You don't have to get these modified keyboards or keyboard mimicking hardware necessarily to test if your app is working with keyboard. So yeah, that's about physical keyboard. Then there are switch devices. And switch devices help people with movement limiting disabilities navigate on the screens where they, and also make selections on those screens that would be typically done by, touch or keyboard or mouse if on computer. And there are two types of switches. There can be this one switch solution where one switch handles basically everything, navigating, selecting, all the other possible actions. And then there can be, or there are these switches that have two switches, one for navigating and one for selecting and other actions. And switches can be either these so-called traditional switches, so there is large buttons, either one or two in different forms, but also it can be anything from eye tracking, so one movement, when you look at left, then you select something, and then when you close, I was supposed to say that when you look left, you are navigating to the next item, and then when you close your eyes, you select. So, or other, facial expressions as well. Then there can be joysticks, type of things, or zip and puff devices. So like zip can be one and then puff can be like another switch basically. And actually one of the most famous switch device users was actually Stephen Hawking. And he, especially after losing his ability to move, he was using a cheek switch to navigate and use, well, mobile devices and also to speak, because he needed that to be able to express himself. So there are there are multiple implementations of switch devices, but they all work the same way from technical point of view. Then there's voice recognition. And voice recognition is for people who prefer to speak and kind of like command their mobile devices to speech instead of, for example, touching or keyboard or switch device or other ways. And this voice recognition might be already familiar to you, because these voice assistants such as Alexa or Siri are well, fairly common these days, and people are using voice recognition to communicate with their devices. So there is that. And the last, I wouldn't use input method in this case, but the last thing I'm going to mention here is zooming and screen magnifying. And this consists of multiple possible things that user can do. And one of them is using larger font sizes. So user can switch font sizes to be larger on their operating system settings. And your app should respect that, but also if it respects that, you should check that the layout doesn't break when the font size is increased, and that it's still usable when font size is increased. And another thing is zoom levels. So user might prefer having like larger zoom level on their device, and so that it's not just the text, but everything else is bigger too. And then there is screen magnifying. It's another software, and user can use it to zoom parts of the app so that they can see them better. And people who use these solutions are often people with low vision. Alright, so we've talked about screen readers, physical keyboards, switch devices, voice recognition, and then zooming and screen magnifying. But what does this mean for a developer? Well, this means that you need to think about more than just touch, and you need to really like pay attention to these different input methods and test with them. And I have a couple of kind of like easy to start with tips how to make your app more accessible for different input methods. All right, let's start with visible focus styles. So when user navigates with the keyboard, they rely on focus styles so that the element that's currently focused is highlighted in some way. And why do you have to think about that? Well, first of all, you need to create visible focus styles. Usually the default focus styles, they aren't that visible, so I'd suggest creating really like custom focus styles that are visible enough. And when I say visible enough, and sorry, that contrast should be, sorry. So the color contrast should be high enough, or the contrast ratio should be high enough. And when I say high enough, it should be compared to high enough compared to the background and also the component it's highlighting, so that it's really visible there. And just want to mention one reason why visible, or like an example where maybe we all understand why these visible focus styles are important. Because, you know, when navigating with keyboard, and if there is no focus styles, or like the focus is not visible at all, it would be the same as if you were using your computer with a mouse and the cursor is hidden. There would be really hard times to try to interact with your computer if you couldn't see the mouse cursor. So if you don't have visible focus styles, it means the same thing. User can't really use your app. Right. The second tip is to annotate headings. And one reason for this is that users who use, for example, screen readers, they like one way of navigating is by headings, so that they can find fast the important part if it has heading and it's correctly annotated. And in the world of web, it's sort of easier and clearer because there you have these H1, 2, 3, 4, 5, 6 tags which are used to annotate headings. But in the mobile world, it's not that clear because there are no such elements. So usually headings are created with like text views or like text components. And of course, it's important to have like heading styles that communicate for a sighted person that, okay, this one is heading, so it's clear, but it's also important to annotate it programmatically. And you can do this via accessibility role. So here I have an example of a text component that has text for custom header. And I've omitted all the other properties, but here is a property accessibility role which is set to header. So this way you can annotate headers so that assistive technology knows that this one is indeed a header or heading. All right. The next tip is to add name, role, and status if needed for custom elements. Of course, I want to say that when you are creating user interfaces, stick with the semantic elements. So if you are creating, for example, a button, use that button element because it already has so much accessibility baked in, and you don't have to do so many things to make that button accessible for users, or other semantic elements for that matter. But sometimes you really need to create custom elements. And when you do, remember to add name, role, and state if it's needed for that element. I have an example here, and it's basically a custom button. I still want to emphasize that use the button element, but still, like, I wanted to take this one because it's maybe the easiest one to demonstrate. So that's why I'm still kind of creating this button. So this is just an example. Don't do this, use button element, but let's use it as an example. So here I have a touchable opacity, which has a text element inside it. And the text element has text to display, which is name. So that's the name, basically what I'm saying, that add name. And when I'm talking about name, I mean that it's the label for the element, basically. So that's what assistive technology users hear, for example, when they are navigating, so that like there is some clear name that they know that, okay, here is this text to display in this case. Then there is again this accessibility role, which is set to button. So that's also an important one. Remember to set the role. And then in this case, let's imagine that this button or custom button should be disabled at some point. And I've set accessibility state and its disabled attribute to false. And it would be true in some cases. But it's just to demonstrate. So this one's example of setting the stage. There are other stages or states there. So disabled is just one example. So for example, is expanded if building something that could be expanded. So some accordion type of thing you might need, this is expanded state and so forth. Right. And then the last of these tips is to respect reduced motion. And now I'm coming to, because at the beginning I mentioned about reduced motion and I use it, now I'm coming to it. So there are people, users, who don't want to see animations on their apps or want to see reduced animation on their apps. Reasons for this might be anything from getting distracted because of animations to having symptoms triggered by these animations. And these symptoms can be anything from nausea to dizziness or other not so pleasant things. And these people have the option to turn reduced motion on the operating system level settings. And when we are building apps, we should respect that setting so that when these people use these apps and they don't really want these, let's say, fast loading screen animations, that's something I've seen out there, then they can opt out from those. And from technical point of view, we can find out if user has this setting on via accessibility info APIs method is reduced motion enabled. So if it returns true, then it's enabled, and you should think about the animations and not show either not show them at all or show a reduced version of them. And if it's not enabled, then maybe you can have these animations, though I would advocate for not having too many of them. But that's completely a different talk and different topic, so not going into there right now. All right. And I have a couple of more tips here or like more general advice when it comes to accessibility and like building apps that work for different input methods. So first of all, no semantics. I already touched this in the previous slides, but really learn about semantics and use them. So that's the first thing. Then learn more about different technologies related to accessibility, because we just, as said, my goal wasn't to go over every piece of information there is about these things. So I would say that learn more. Make the effort to learn more. And of course, test with different input methods. So not just with touch, but remember to test with screen readers and keyboards and switch devices. And just in general, learn more about accessibility. So that's like, I think it's a good advice to any developer who works with user interfaces, because when we create accessible apps or sites or like basically whatever, they are better for every user. So there's that. Learn more about Actor. So there's that. Learn more about accessibility in general. And as I mentioned somewhere in the beginning, my goal is to kind of provide a starting point or like, I'm not going to talk about every single detail there is to know about this because I just don't have enough time. And I also know that there has been lots of information still. So I just want to share the key takeaways I really hope that you remember from this talk. And I also hope that this talk has provided you some vocabulary and kind of like starting points to start learning more about these concepts and things. Because sometimes, well, starting to learn about something, it's really hard if you just don't know even the vocabulary or what you should search or anything. So I hope that this has provided that. So what I hope that you remember from this talk. First of all, users use mobile devices differently. Not everybody uses touch to interact with your app. Remember to test with different input methods. This is really like something that I really hope that you remember from this talk. And educate yourself. So learn more about these themes, learn more about accessibility, learn more about how people with disabilities use their mobile devices. All right. So thank you for listening. My name is Eeva-Jonna Panula, and you can find me from Twitter. I'm Eevis Panula, so EEVISPANULA. And you can find all the other information or contact information from my website, which is eevis.coach, so eevis.codes, and you can also see them at the bottom of the slides. So, thank you.
Thank you. Thank you so much for this important talk. The accessibility is very important, but often overlooked. So I think we have some grounds to cover there. We will have a 15-minute break right now, and we'll be back in 15. Be sure to be back. See you.
This conference is brought to you by CodeStack, React and React Native development experts.
Hello.
Hey, hello again after the break. We have 4 talks ahead of us, our sadly last section of React Native EU 2022 conference. And first talk in this last section is called Performance Issues, the Usual Suspects. From BAM, it is Alexandre Moureaux.
I'm very happy to be talking to you at React Native EU. I'm Alex, I'm a tech lead at BAM. We develop mobile apps in Kotlin, Flutter, and of course, React Native. And I'm particularly interested in the subject of mobile apps performance. And so I tend to audit a lot of apps performance and help teams analyze their performance issues. And as it turns out, there are several issues that come up quite often. So for funsies, I thought, hey, I will code an app with most of those issues so that we could have the joy and the fun of debunking them and sorting them out together. Let's dive in. So this is the app. It looks quite good on iOS with a nice countdown banner to React Native EU, list of tweets, etc. But based on our research, a lot of our users actually have lower-end Android phones, like this one, a Samsung J3 that I'm sharing via screen copy. And if I try the app on this one, and it's a release app, this is what it looks like. Actually, it takes a lot of time to load, and the countdown is not even working. You can see that it's basically skipping a second all the time. So we have massive issues to investigate. But first, let's measure, because we severely need to improve the startup performance of our app, right? And we're going to do so over several iterations. But it would be nice to have a performance metric, a measure that we can use to make sure that every iteration actually improves our performance. And for that, we built a Flipper plugin called React Native Flipper Performance Monitor that you can use to track JS and UI FPS. However, whenever I talk about measuring performance, I always say that, performance measures are hardly deterministic, so you need to make them as deterministic as possible. And to do that, I always say that you need to average your measures over several iterations. As much as possible, keep the same conditions for every measure. and ideally automate the behavior you want to test, like scrolling, clicking, etc. But all of this is kind of tedious. With the plugin, you need to click start, you need to do some stuff, you need to click stop, then you need to do it again. There is no average anything, so you need to do it on your own. But today, I am very happy to introduce that we have a CLI version for it. And what's great is that it's fully automated. It requires no installation on your app whatsoever, which means that it can actually run on any Android app, even a release app, an Expo app, even a native app, not even a React Native app for that matter. And so let's try it out. So our tool integrates quite well with any end-to-end testing framework like Appium or Detox. But here, just using some ADB command to start and stop the app, we can basically declare a performance tester coming from our module, profiler/E2E, and make it iterate over a test scenario that just does, well, I just stop the app and start the app and then measure performance for a duration of 15 seconds. Then we make it write the results. All right, so wait, let me save it. And let's just run it with TS Node because it's a TypeScript file. And we will see that it's running the 10 iteration. It's going to be starting the app, measuring the performance for 15 seconds, stopping the app, and doing that 10 times. So it's going to take about 3 minutes, so I'll skip to the end of it. So now that this is done, it finished the 10 iterations. It outputted a JSON file. Luckily, we can run npx per profiler/web reporter on this JSON file to open it in a nice view. And ta-da! Yeah, we can see all the results and a bunch of metrics. Basically, we have the score, which is 31 out of 100, which is really bad, and a bunch of metrics such as FPS, CPU, and RAM usage. Specifically here, we see that the thread MQTJS has a heavy usage, and that's the JS thread. So actually, here you see the graph for the JS thread, and you can see that it's requiring a lot of CPU all the time, even after a few seconds. So we have a lot of issues to investigate on the JS thread. Since we have an issue on the JS side, we should use first React DevTools. Here, I'm actually using it on my higher-end Android phone because the JS side was so dead on my J3 that React DevTools was actually not working. And here you can see with the performance monitor that actually the JS is struggling even on this high-end phone, and nothing is happening. I'm not doing anything. So let's try to figure out what's going on. First, if you use React DevTools, make sure that you check this, record while each component rendered while profiling. This will be very useful. So we should click here to start recording and profiling the performance. And here we can just wait a bit without doing anything because, well, apparently something happens that completely destroys the performance already. So let's stop this. All right. So top right here, we can see that we have 12 commits. So commits are phases where React actually applies any changes. It renders new component, it updates some components, on the native side, basically. And here, well, we can see that we have 12 phases, 12 commits where React applies any change. And, well, for example, if we take the first one here, we can see below the hierarchy of components in our app, starting with the root component, React Native Feed, to some, well, basically the leaf components. Everything that is in gray is not rendering, so that is quite good. However, everything that is in a different color, like green or yellow, is actually rendering or re-rendering. So for example, here we have Tweets tab rendering, and it's quite expensive to render. So if I click on it, you can see that it's taking a total of 400 milliseconds to render. That's the total time. And its self-time, aka the time that it took to render without any of its children, is already 217 milliseconds, which is weird. So basically, Tweets tab is expensive to render. So okay, that's an issue we're gonna have to deal with. But first, why is our tweets tab actually re-rendering when, nothing much is happening? All right, so React DevTools actually tells it to us. It says hook 16 changed. Okay, so at the moment, the only way to know what is this hook 16 is to go on the Components tab. And here on the Tweets tab component, you have the list of hooks. And we should check which one has 16. And actually, the one that has 16 is in use countdown, because in our hook called use countdown, we have a use state. Well, we could have guessed it because, well, the commits actually happens every second or so. But why is it that every time the countdown, is happening, or tweets tab is actually re-rendering? All right, well, let's check the code. Here it is. You can actually see that we have use countdown here inside the render of tweets tab. And in this use countdown, we use a state to store the countdown timestamp, and we set interval every second. Basically, we change the state, which makes a lot of sense. I mean, I don't really know a better way to do this. However, here, since this is inside tweets tab, this means that every second, the whole of tweets tab will update. So, we could memoize the rest of the component that doesn't need to update, but also we could be wondering, like, why is this in tweets tab? Because there's this whole component here, which could basically be extracted into its own. A countdown banner, for example. And this new component here should have the use countdown. And then, of course, yeah, we need to add countdown banner here so that it reappears. Maybe I just need to update. Oof. And already, just moving components around. Oh, actually crashed. Okay. Just moving components around, we should be able to see that performance is already much better, because now whenever the countdown updates, only the countdown banner re-renders. So you can see that now the JS is almost back to 60, sorry. And so if we go back to the Flipper DevTools and we try to record something, it should be much better than before. Remember, before we had commits of 500 milliseconds. Now we have commits of 18 milliseconds every second, because only this guy here, the countdown banner that we created, is re-rendering. So just by following, single responsibility principle and making sure that what needs to update is at the right place, we've already made significant improvement to the performance of the app. But could we even go further? Because here, basically, we have data updating often. And that happens quite often, like, for example, for live matches, for football, or stuff like this. You might have, like, data updating very fast. And in this case, you want to make sure that your updates are contained to the smallest component possible to be at the top performance. For example, here, when the countdown changes, we basically just want to re-render the second count here. I mean, sometimes the other ones, but usually it's only the second here that needs to re-render. And even, this whole countdown banner already takes 18 milliseconds to re-render. So can we do better than that? So to do this, the best way is usually to use a state management tool. And for this, actually, Jota is quite nice, because I won't go into too many details. I might write a blog post or something about this, but you can basically create an atom for your countdown with Jota, derive the value that you want for days, hours, minutes, and seconds, and then you can create some React component that just display text, days, hours, minutes, and seconds, and use them into your fast countdown component with days, hours, minutes, and seconds. And so, if I do this and replace this guy here with fast countdown and disable this here, so I don't need this anymore. Whoop, whoop, whoop. Let's see what this gives us. So if I go back to Flipper, I take another profile, I stop profiling, and now each of my commits actually is only 0.5 milliseconds to render. I'm not sure what happened here, but well, anyway. Because actually it's even hard to find what I actually updated, because it's this tiny guy here, start countdown, and then it's well, it's harder to find than I thought, and then it's this guy here, seconds, that is really small, really cute and tiny. Boop, 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 boop. And so now, every second, we basically just have 0.4 milliseconds of a render happening. So this is much better. We'll still have some issues to check, actually, because the JS is still not at 60, and the startup, as we were able to see, is not fantastic. But before moving on to the rest of the issues, we could measure the changes on the J3. And luckily for you, I already took those measures, and since I'm quite paranoid about making changes in development mode and making sure that those changes actually impact production, I decided to measure all things in production. And so with the send script as before, I was able to have a new JSON file with all the performance measures. And using performance profiler just like before, I can, so per profiler / breadbook order just as before, I can open it. But if I pass in several JSON file, so this is the previous JSON file that I renamed to init.json, and this is going to be a new one, which I measured on this version of the app called FastTimer. If I pass several JSON file to the web recorder, then I can actually get a comparison. On the left, we have the previous version of the app, and on the right, we have the new version with the FastTimer. So you can compare the different metrics, but the biggest change is, well, first the score went from 31 to 53, so yay. But the biggest change is that we went from the JS thread being blocked for an average of 9 seconds to an average of less than 4 seconds. And indeed, if we open the CPU graph, we can see that actually the JS thread in purple for the second version is, descending much lower than the first one after a few seconds. However, well, we'll still see that, the usage is super high in the beginning, so we can investigate further the start of the app. The thing is, yeah, we should do this with Flipper again. The thing is, it's kind of tricky to investigate the start of the app if, well, whenever you reload the app, actually the React DevTools will reload as well. I have a stupid trick to deal with that. It's just that at the root of your app, just add a button that you display conditionally. It's very silly. Basically, we have a button called render app. When I click it, it will render the whole app, which means that now I can actually use React DevTools, click start profiling, render the whole app, wait a bit for the app to render because we can see that it's still pretty heavy, and reminder that I'm still on S10 actually. So I'm analyzing the performance issues now on S10 because it was so awful to do it on the debug version on the J3, but the performance measures with the big tool were made on the J3. On the release version. So if I stop recording, stop profiling, yeah, we can see tons of commits, but those very small commits here are just due to the timer, which we fixed. So let's just hide them, let's hide the commits below 10 milliseconds. Okay, now we have only 18 commits. So we should take a look at the biggest ones, I guess. We have this one, which renders the tweets tab, and it costs about 800 milliseconds. And we have this one, which renders the tweets tab, and it takes about 600 milliseconds. And we have this one, which renders the tweets tab. Okay, so we have 3 commits rendering the tweets tab. So again, the tweets tab is pretty heavy to render, and we should investigate that. But the question here is, why is the tweets tab re-rendering? So again, we can check. We can see that the tweets tab is re-rendering this time because hook 12 changed. So if we check in the components, wait, I can just select it here, and then in the component it will already be selected. And I can see that, okay, 1, 2, 3, 5. So I'm using React queries, so this is why you have the use query here. This the 6, 7, 8, 9, 10, and so we have here 12. So 12 is a use state inside use base query inside use query. All right. And I'm guessing the other commit update is because of the other use query. Hook 7 changed. So if we check, yeah. So 2 use queries are actually updating my tweets tab. So if we take a look at the code, of course, on tweets tab, we can indeed see that we have a use feed, okay, loading the feed, and we have 2 other use queries. And those use query are fetching the user and the user stats to display here the header, the user header. However, it's kind of the same as the countdown, right? We fetch the user, the data of the user changes, and so the whole of tweets tab is re-rendering, and same for the user stats. So I think we should just do the same as before. Because here, I mean, of course, like we could memoize this to say that this doesn't change if user changes, but it's better to just separate, or wait, we actually do have a component called user header, so let's just go in it. And instead of returning just a simple component and taking the user header, we should just get those 2 queries here. And whoop, user does not exist. Yep, because I'm not so great, and this is live recording. You can already see that I'm not so great at live coding, even though this is actually a recording. So luckily I'm not doing this on the stage. Anyway, yeah, we refactored the hooks to actually the use query hooks to get into the user header, because user header should be the component responsible for fetching its own data. And this is actually the second issue I wanted to talk about. Is that you should, it's kind of the same as the first one, but you should follow single responsibility principle. Each component should be able to load its own data, because otherwise, if you load the data, for example, at the root of your app, then the whole app will re-render so many times, and it's very annoying to try to memoize everything and sort through that. Like, memoizing would help, yes, but it would be easier actually if everything is, you know, in smaller components, and then you have less re-rendering. So if we check it in React DevTools, again, in the profiler, so let's see here, profiling, render app. I mean, still pretty bad, so we have some other issues, obviously, but let's stop profiling. And now we have a bit less commits, right? All right, so here we have our first commit basically rendering tweets tab for the first time, but now at least tweets tab is not re-rendering in the other commits. So, all right, we still have some very expensive commits coming up, but before we dive into them, let's measure on the J3 on the release version of the app. So luckily for you guys, I've already built the release version of the app, and I've already taken the measure. So let's compare between, the previous JSON file to the new JSON file that I've entitled to user header. And let's open it. And we can see that our score went from 53 to 67, just by moving some hooks into another component. And our total, JS was dead for only 1.4 seconds now, so much better. But let's continue. Because if we take a look again at the Flipper DevTools profiling, we can see that we have a very heavy commit here. And this commit actually renders likes tab, media tab, and replies tab. But when we open the app, why would we render those tabs? We don't need to render them. And so this is the third issue, is you're rendering too much items. You're rendering some stuff that you don't need to be rendering. In this case, this is easily fixed because, well, we're using natural top tab navigator from React Navigation, and luckily it has a you can pass a screen option here with lazy set to true. And so if you try this again, let me reload the app up. And so if we try the trace again, in DevTools, render app, all right, we can see that it's already kind of faster. Stopping, yeah, we see only 8 commits now, and it's much better. It's much better than before. So same as usual, if we just take a look at the performance measures with our super tool and compare to user header with our new measure that I already took for you guys, because again, it takes still 3 minutes and there would not be time in the recording. With lazy tab, we can see that we went from 67 to 75, a small improvement, plus since there was less item to be rendered, actually CPU usage went down quite heavily on average. So this is quite cool. All right. But okay, I've been avoiding this for a while now. Tweets tab is really heavy to render, right? It takes 700 milliseconds, and here we can see that its self time is 374 milliseconds, so more than half of, I can get that the list is heavy to render, but what does this mean? So this means that actually in the render function of Tweets tab, there is something that is really heavy, some heavy calculation probably. And sometimes it's hard to figure out just by looking at the code or by React DevTools alone. So in those cases, I like to use to actually record a trace, a trace with the Hermes profiler, and then open it in Google Chrome to see what's the issue. And so let's do this. All right, so you need to make sure, I'll reload the app. You'll need to make sure, if you want to do that, that in your app build Cradle, you have bundle in debug activated and set to true, which is not the case here. So let's add it. This will make sure that what you see in your trace that we will see will be actually readable. I've rebuilt the debug app with it, with bundle and debug, and so, well, documentation about this is pretty detailed on the React Native documentation, but let me show you how it's done. So you want to press T here, enable sampling profiler to start recording profiling, just like we would do on React DevTools. Then do whatever you want in your app. In our case, it's rendering the app. Press D again, enable sampling profiler again, which actually disables it, and it saves a trace on the device. And then you have this neat comment, React Native profile Hermes dot, to make sure that you actually pull the trace file and convert it to something that can be read from Google Chrome directly. So let's open Google Chrome. In Google Chrome, we can open the Developer Tool, Performance tab, and here we can load the trace that we just downloaded from the device. All right, it's going to be processing it, you might see, but you can ignore this, some issue in the console. And yeah, you should see only one thread, well, the JS thread basically, that you can expand here. And this is basically a flame graph similar to what you would see in the React DevTools, only way more detail, because you can see some stuff, you know, what actually happens inside the React code even. And well, in our case, it's Tweets tab that interests us, so let's search for it. We have two results here, but it's very small. We have another result, which is here, which is more interesting. I can zoom in with W on it. Let me go down a little bit. And we can see here that it takes 400 milliseconds to render. Because of use feed, that takes 400 milliseconds to calculate. Because of something called filter tweets. And so let's check why filter tweets is heavy. Because it's calling get tweet weekday, which takes, like, it's calling it a lot actually, and it takes every time something like 30 milliseconds, and then it calls parse, which is already quite heavy. So basically, filter tweets here is really too heavy to calculate, because it seems that there's a filter and then a find on the tweets, and then some heavy date calculation. So actually, you know, whenever you deal with dates, just parsing the dates with any tool can be quite heavy if you do it a lot of times. So checking our code, we have indeed our function filter tweets, which is quite stupid. It runs through all the tweets and it checks if, you know, the parse date in format English is one of Monday, Tuesday, Wednesday, Thursday, Friday. So basically that's our new issue, a function with high algorithmic complexity, and we can just very simply change it to something that, you know, we just take the weekday from it, from the date. We don't even need to use parse. Here I was using datefns, and we'll return if weekday is over 1 and under 5. So now if we go back to our React DevTools, and let's reload the app first. There you go. If we go back to the React DevTools and we render the app, I'm just gonna quit that, and we stop profiling, we can see that our heavier commit is here, rendering tweets tab, and yeah, basically tweets tab takes only 1.7 milliseconds to render now instead of time. I mean, the rest of it is basically just the list rendering. So let's check our measures, and with our super tool, surf profiler / web reporter. And so this time we'll be comparing our previous measure with the new one, and we should see a significant improvement, especially in CPU usage. We can see here that it's going down a lot, especially because the JS thread actually is not even reaching, I mean, the highest point is 70, and then it's much better than before. All right, so that was the fourth issue, algorithmic complexity. All right, so where do we stand now? We still have a lot of CPU usage, high CPU usage, but not for so much time. But our average FPS is not very good. It's always around 50. So what's going on? So on the S10, I cannot see that. I see that it's always at 60 FPS. So let's bring up the debug app on the J3 now, because this is where we can see that it's not running at 60 FPS. So indeed, we can see that the UI thread FPS is going down even when we do nothing. Also, the jest thread is actually following because jest thread measures get reported on the UI thread. So if the UI thread is down, well, the measures are down, not because the jest is too busy, but because the UI thread is actually busy. But anyway, we have issues on the UI thread. What can we do? We can go to Android Studio here, and then in the Profiler tab here, we can attach it to our app. And if we select CPU, here we actually have several tools that we can use to, I encourage you to try them out, but today we're going to try the Java Kotlin method trace recording. And basically, okay, I'm starting recording, what it's going to print out is a plain graph, just like in Chrome for the JS side, but here on the native side, everything that happens on the native side. So in our case, we care about the UI thread. The UI thread is also named the main thread, so let's check this guy out. And the UI thread is responsible for displaying 60 frames per second, So every 16 milliseconds, basically what happens is we can see here there is something called a class called choreographer calling doFrame, and this should run in less than 16 milliseconds to make sure that the app is smooth. And here we can see everything that it's actually calling. We can see that indeed this guy here is taking more than 16 milliseconds, 50 milliseconds, which is pretty crazy. So the question is, well, what's going on? And we can see here, for example, that it's calling React Native animated module, doFrame, update nodes, etc., etc. And deep down, we're setting some transform. So we can see that something heavy is happening on the UI thread. We have a running animation. We have a long running animation. And here, then we can see that it's actually drawing to be, like it's updating some animated value with transform, and then it seems to be updating those. And this is what's actually heavy. Like this should happen in less than 16 milliseconds, but here it's taking 50 milliseconds. So here the question is, what is this running animation? So wow, this is not one of the most common issues I get actually, but here it's not this guy here that's using animated, but actually we have our skeleton loader here, which is still running behind the list. For example, if I comment children here, it's actually running behind our list, and this is what's actually causing the drop in the UI thread. This actually happened on 2 projects that I know. It was just to show you that in this case, we can go through Android Studio to figure out what's going on. So obviously, if we fix this and make sure that the skeleton loader here does not display, when it's finished loading, then it's going to be much better. So let's check again our performance with our script and compare it with before. All right, we can see that this is a lot better. On the FPS side of things, specifically, we're achieving smooth 60 quite soon. But can we do even better? Well, one last method of investigation is to check the thread usage. Usually most of your issues would come from the JS thread in a React Native app, but here the JS thread is actually, not doing much because we improved it so much. If we check the list of threads below, we can see actually that the thread consuming the highest CPU usage is the render thread, and the thread called Chrome in POC or something. A thread called com, and you can see here that it's running heavily, it's running steadily at 20%. all the time, it should, make you guess that we have a heavy web view. And if you have web view where you don't control the content, like ads or whatever, like ad mob, it can actually completely kill the performance of your app. And here, just a small web view has a massive impact. In our case, the web view is actually this. I took the GIF of the website for React Native EU and I put it in a sample page, and I'm displaying it in web view. And it's basically killing the performance of my app. Well, not killing, but it has a big impact. Because, for example, if I replace it with a GIF and then take some new measures, let's see what it gives us. And indeed, we're finally at 96 out of 100. Woo! Alright, this was a lot. We encountered so many issues. The first one was that data updating often should be contained. That was the countdown. Second one was about the header needing to fetch its own data. The third one was about the tabs that needed to be lazy and not render all the tabs where necessary. Fourth one was, the feed needing to filter and it was costing too much. Fifth one was the animation running in the background while it was not needed. And the sixth one was about a heavy web view. And I haven't even talked about some other issues that you might encounter quite often, like list. I guess just give FlashList a go. Or images, just, follow the best practices out there. We also used Android Performance Profiler or new CLI tool to measure, and we used React DevTools, Performance Profiler, Android Studio, and just investigate threads to analyze all performance issues. All right, I hope this was fun for you. Thanks for your attention. Give the plugin a go. You can follow me on Twitter if you want. I tweet mostly about performance. Thank you, and have a great conference.
Well, thank you so much, Alexandre. And now, I have a huge pleasure to introduce to the stage ex-Cold Stacker. He's actually ex-head of delivery at ColdStack. He is, of course, my former boss. So, give it up for Michał Chudziak.
Hello everyone, and welcome to my presentation. I hope you are all doing great, those who are here in Wrocław and those who are watching us online from all over the world. For those who don't know me already, my name is Michał Chudziak, and I'm an independent consultant on React Native. You can find me on GitHub, Twitter, and LinkedIn under the following handle. And if you'd like to know me better, I invite you to visit my website or simply talk to me after the presentation. Before I begin, I'd like to thank the organizers for inviting me here today. I spent over 6 years working at ColdStack in the development and leadership roles, and I have to admit that it is one of the best places in the world to grow as a software engineer. So if you are looking for opportunities to grow, I recommend you joining their team. As you can see on the screen, our topic today is answering the question, how to actually improve the performance of a React Native app. And my talk is particularly relevant to those who want their app to perform well on every platform, those who have tried to improve the performance with little or no success, and those who had managed to improve it only to have the issues suddenly come back. Ultimately, it's for everyone who wants to deliver the best possible user experience to the users of their application. Okay, so let's start. Suppose your average application rating diminished by half a star only over 3 months due to an increasing number of performance issues. This caused a 0.5% cutback in the user base and significant revenue shrinkage. So have you ever wondered how would you respond? I will come back with the solution soon, but before I do that, let me quote a few facts. Nobody likes slow apps. Statistics show that increasing customer retention rate, even by just a margin of 5%, has the potential to increase the profits by 95%. And what's more, most companies agree that retention is cheaper to execute than acquisition, and the customer's perception of their brand is directly affected by their initial impressions when engaging with it. Ultimately, losing a customer due to the poor application performance or stability is preventable and should never happen. Here are some interesting quotes from industry leaders to back up this thesis. It doesn't matter what market or industry you operate in, because performance is critical for everyone in 2022. Companies compete for our attention and screen time, and more devices are adopting refresh rates well above 60 Hz. Everyone wants smooth and quick interactions. The content has to be there, fast. You have to deliver, or you're out. Okay, so now that we know that performance is important and that it's not so good in our app, it's time to roll up our sleeves and get to work. So have you ever been in such a situation? Back in the day, I was, and I wasn't sure what the reason was or how to fix the issue. So I did what every developer does in such a moment. I Googled it. And in my Google search, I ran into many tips and techniques that I could apply to my code base. Different articles and YouTube videos told me to use scrolling lists, use only high-performance components, use native driver, use memoization, try using a different navigation library, remove console logs, use external libraries, don't use external libraries. And there was so much information, sometimes contradicting itself, that I couldn't decide what to do or where to start. So I followed my intuition, guessed the problem's origin, implemented the techniques in question, and failed miserably. So the improvements were slight, almost unnoticeable, and the user experience was still suffering. And it's not just me. Recent research indicates that even though the majority of organizations have improved their ability to collect the performance data, many of them are also unable to identify and resolve these issues in a timely manner. So after a rocky start and some back and forth, and with my help of my colleagues that are here with me today, I managed to optimize the app. But the process was painful and took way longer than initially expected, as I played hide and seek with the bugs. So what did I do wrong? As the time flew by, my team and I approached several other similar projects. And our approach became more structured over time, and we were able to deliver better results more quickly. So my experiences led me to several conclusions. First of all, while working on such projects, you have to avoid guesswork as much as possible. Poor assumptions can lead you to false results. So always base your decision on data. Otherwise, you're wasting your time. Usually, performance issues are like a resultant force. So several factors impact your application. And there's no secret sauce, no magic elixir that can fix it all at once. Sometimes one simple change improves performance by a lot. But usually, there are several factors that needs to be optimized, which we've just seen. And it takes time to improve. And it should be a continuous process. Finally, I've seen several teams, usually working on a large projects with high fluctuation, that needed help with performance periodically. And these days, there's ever-increasing complexity of business requirements, platforms, paradigms, etc. And the first rule of optimization says, do less. And it's really hard when you have to do more. Ultimately, the user interaction with the app is a process. And the code that drives the user through this experience serves as a foundation of this process. So we have input, some interaction options, and the code that backs it all up. And we expect a final result. This process could be optimized, like any other. UI and UX experts are doing it from a layout perspective, but we can also improve it from a purely technical side. And you know what? It turns out that humans are good at optimizing processes and have developed many techniques and methodologies around that. Some of them are decades old, well-tested, and continuously improved. So during my time as a manager, I learned some of those and participated in several optimization projects. So I found a lot of similarities between their stages and the technical improvement projects. And combining the knowledge I acquired while working on Lean Six Sigma projects, and by the way, Lean Six Sigma is the state-of-the-art methodology for improving processes and work efficiency, with my previous experience with the optimization of the React and React Native apps, helped me to improve the structure and overall efficiency of my work and performance optimization efforts. So let me present you with the methodology that's commonly used for process improvement or solving business cases, and it's very data-driven and well-structured, but what's best about it is that it can be well applied to the optimization of React Native apps. It's called DMEC, and this acronym stands for the first letter of each phase. So let me walk you through each phase and show you how I usually apply it to React Native. The first step in our process is a define phase. So this is the moment where we should focus on defining the problem, project goals, opportunities for improvement, and customer deliverables. In short, we need to define where we want to go. It's like when we are planning a vacation. We scour through different destinations and choose the one that suits us best. So we start by listening to the voice of the customer. The voice of the customer is a term that describes your customer's feedback about their experiences and expectations for your app. And by listening to the voice of customer, we can better understand what the needs of our customers are, what their expectations and preferences are, and what problems they are facing. We can listen to it by building a voice of customer program, implementing feedback forms within the app, or evaluating users' ratings and comments on the app stores. But voice of the customer is often vague and hard to measure, so we need to translate it into something more specific and easily measurable. And the measurable elements of a product or service that clearly show the customer satisfaction levels are called critical to quality, or CTQs. So, as you can see on the example, we take one of the VOCs, which is usually constructed from the clustered feedback, and we break it down into measurable components. So in our case, customers want a fast checkout. So after analyzing cluster components, we know that this means a swift checkout process, short wait time on checkout flow, and smooth interactions and transitions between the screens. And this is further decomposed into CTQs that are measurable and easily trackable. Another handy tool is user path analysis. It's good to know what our users do in our app in order to know what's most important to them. And with good tracking, we can analyze path funnel data, which shows what areas of the app were visited, in what order, or trace the paths on the individuals who end up uninstalling the app. Earlier, I mentioned that not everything can be fixed at once, and this fact is very important to remember, because there's usually a lot of pressure from a business that we have to deal with, and at this point, you should choose what's most important in order, and the order in which you will optimize things. So don't spread too thin, be laser focused, and tools like prioritization matrices can help you choose. Ultimately, we need to define where we want to go, and this means we need to know what we want to improve and what the expected results are. So outline the metrics that will be measured and what the final targets are. And it's a good practice to put these goals along with the project scope, direction, and motivation into a project charter, as it gives a good overview and on the project and facilitates the communication with the business. Now that we know where we want to go, it's time to assess the starting point. So the route to the beach is different when we are in a 5-star hotel with an ocean view and when you are in the middle of the swamps. It's time to assess the extent of the issue and quantify it with the data. The measure phase is all about collecting as much data as possible in order to get the actual picture of the problem. This means we need to ensure that the measurement process is accurate and precise. And even though I said we need to gather as much data as possible, you should be efficient in your data collection, as the complexity in software engineering is high and you can easily get overwhelmed. So it's really helpful to prepare a data collection plan and metrics, and at this point you can describe the data, select and validate the collection methods, assign team members, and prepare a data repository. And after we're done with that, we move to profiling. React Native is a framework that lets us build user interfaces using JavaScript and render native UI components under the hood. So this raises a question of whether to profile JavaScript or the native side. And there's no clear answer to this question, as it heavily depends on your tech stack and architecture. Usually, it's a mixture of both. However, the majority of performance issues in React Native come from the JavaScript side. One of the most useful tools is React Profiler. It's a built-in API that helps us measure the number of renders and the amount of time necessary to render a component. It's very handy, as the performance issues often come from unnecessary rendering. And it's mostly designed to work in the development mode, but you can use a special version of React to measure in production builds. The second tool, a library called React Native Performance, is one of the most useful profiling tools for JavaScript in React Native. And it's an implementation of the performance API from the web APIs for React Native. And it lets you place native markers in the code and measure the execution time. It also allows you to verify the network requests and export several useful native markers. Most of its functionalities work both in development and production. And by the way, there's a Flipper plugin that you can use to visualize the output. On the native side, the most common way is to use profilers built into native IDEs. Within Xcode instruments and Android Profiler, there are many tools to monitor resource consumption and network traffic, as well as process trace across the threads. You can gain a lot of useful insights by analyzing the results. So I strongly recommend spending some time learning how to use these tools, or watching the presentation that were presented before me. And another technique that's simple and straightforward is using stopwatch, but don't do it. It's better to use screen capture and analyze the video frames. It's way more precise, as we don't rely on our reflexes, and trust me, they are really bad in my case. Another tool, or more accurately set of tools, is Flipper. Flipper comes with several plugins that can help us measure the different KPIs in the development. And you can use the Perf Monitor plugin for a lighthouse-like experience, List Profiler plugin from Shopify, or a plugin that supports the React Native Performance library, which I've just mentioned. There are several aspects to consider while doing measurements, and the most important is measurement variation. So due to different environments that we can wrap our app in, we have to be very careful and precise while profiling. And we should consider different platforms, different operating systems, different phones, etc. And even if it is run on the same device, there might be external factors that impact its processing capabilities. And to ensure result certainty, you should base your measurement on the release builds and account measurement variation. As I mentioned before, our measurements should be accurate and precise, and ensuring both will reduce the measurement variation. So even though these two terms seem similar, they touch on two different aspects of measurement. Accuracy is the tendency of measurement to center around a given value, while precision describes the ability to achieve the same results under the unchanged conditions. So I encourage you to read more about accuracy and precision, as each has a set of factors that impacts it, such as bias, linearity, or stability for accuracy, and repeatability and reproducibility for precision. Decomposing measurements to these factors can help you do a measurement system analysis, but of course it's not something you need to do in every case, but it helps if you want to be absolutely sure. Now that we have all the data, it's time to start the analyze phase. So you can think of this phase as defining a route from point A, which is our baseline, to point B, our target. And the goal of this phase is find the root cause or multiple root causes of our problem. It's good to start by creating a long list of potential issues. So gather your team and outline every factor that could have an impact on certain KPI. There are several brainstorming tools that you might use to help yourself structure the work and discussion and facilitate gathering ideas. I will show you my favorite one in a second, but I just wanted to mention that even if you are working alone, these tools are helpful to organize your thoughts. The tool I just mentioned is called cause and effect diagram, and it's also known as a fishbone diagram. And just guess where it gets its name from. Yeah, you're right, it's a fish. Anyway, the fishbone diagram is typically drawn from right to left, with each bone of the fish branching out to include the data containing more detail. We start by drawing a head. The head should contain a problem statement. So we've already defined several problems in our app and confirmed them during the measurement phase. So I'm going to put a low FPS number on the product catalog screen as our brainstorming subject. Then we identify potential major causes that could contribute to our problem. And in our case, it could be poor measurement, issues with the thread bandwidth, or rendering the list, or bad application architecture. So if you come up with more groups of potential causes, that's great. You can simply extend the body of the fish. And after we're done identifying groups, we outline potential causes. There are many things that could have an impact on poor performance in certain areas. And at this point, we need to create a long list. So put down everything you can think of. Now, as the fishbone diagram shows all of the many possible causes of the problem, we need to narrow the list. So analyze the diagram and choose which causes aren't likely to have an impact on the issue and those which needs further investigation. Outline the factors that you find most relevant, and it will be a bit arbitrary at this point, but don't worry, we'll go ahead and test them anyway. And keep in mind that there might be several factors and root causes for performance issues. As I mentioned before, it's like a resultant force. Finally, once we have defined our hypothesis, for example, prop drilling causes performance issues on product catalog, it's time to find out the truth. So there are a lot of guides on how to perform hypothesis testing by the book using statistical data, but in our case, it's not often needed. What's important is the testing process. So we start by defining a hypothesis, which we've just covered. Then we need to design a test that will help us accept or reject the hypothesis. And it will be probably some proof of concept to compare the impact of a given factor on a final result. Subsequently, we interpret the results and outcomes of such tests and decide whether it has improved or not. Then we make the final decision. Finally, it's time to hit the road. So now that we know where we are, where we want to go, and how to get there, it's time to get our hands dirty. So this is the moment when the optimization technique starts to make sense. You're not the confused sneak anymore. You know precisely what's the root cause of the problem, and you can fix it. But every problem can be fixed in several ways. So before starting an actual implementation, it's good to have another brainstorming session with other engineers. And you can either do it offline with some pizza and sticky notes or online using various visualization tools. There's a variety of solutions depending on your root cause. Many of them are well described, and I have outlined several generic things that you can consider when looking for a solution to your problem. In my experience, problems are usually related to the poor React usage and frequent reconciliation of the layout. And that's not always the case, but it's often that. And after you're done outlining solutions, evaluate their pros and cons and select the one that suits you best. Remember that sometimes the solution that brings the best results might be extremely costly. For example, when you have to do a major architectural changes in your code base. Sometimes you will have to make compromises, and you will have to accept that. Finally, as you and your team have reached a consensus on what to do, just do it. It becomes so simple at this point. So after finishing the implementation, make sure to do appropriate testing, and if results are great, well done. Your app isn't bad anymore. The last step, but certainly not the least important, is the control phase. So we fixed our app, we've started receiving positive comments and ratings, and management is happy with our work. So life's good, but will it stay like that? How can we be sure that it is permanently fixed? This is what the control phase is all about. Not only we need to validate the improvement, but we need to also ensure that it will stay with us. And if we take a look at the performance of the apps over time, we can observe a cycle where refactors and optimizations intertwine with feature development. And as I mentioned before, there's a high level of complexity that we deal with while developing the apps, which is an opposing force to our optimization efforts. So usually, if you do nothing to keep the app performing right, you will experience issues at some point. The performance will degrade if not under control. And there's nothing wrong with that. People tend to look for something to blame once they start experiencing issues. They blame the framework, devices, users, or others. And well, you shouldn't do that. You just have to accept this fact and prepare for it. So, what do we need to do in order for our chart not to look like that, but rather like that? Can we do something to keep the app performing right, the performance under control, and continuously improve it, rather than launch a big optimization project every year? And the answer is yes, we can, and the control is the key. A control plan is simply a strategy to ensure quality. So we can use some of the work from previous phases to define the areas we want to control. We should outline focal points, scenarios, measurement characteristics, acceptable ranges for each indicator, and testing frequency. Additionally, it's good to define some procedures on what to do if we spot the issues. The most crucial aspect of controlling is closely monitoring the regressions. Some time ago, we haven't had many options to do it easily with React Native. Fortunately, thanks to the amazing work of folks from CallStack, Google, and Sentry, that has changed. The first library that I wanted to recommend is Reassure, a great tool to monitor app performance regression on CI or a local machine. You can read about it more on CallStack's GitHub. Then we have the Firebase performance monitoring from Google that allows you to gain insight into the key performance characteristics within your released app. Finally, there's Sentry performance monitoring, which tracks application performance, measures metrics, and displays impact of errors across multiple services. Performance control has never been easier. That covers just about everything I wanted to say about the process, so I hope this information should help you structure the work and achieve satisfactory results. However, if you ever need some help with performance optimization or anything else related to React and React Native development, feel free to reach out to me via my website or any other channel. I would be happy to help. Thank you.
Thank you, Michał. Such a huge fan base here. I think the talk was very well structured, and I really liked the fish joke. Now, for the component anatomy, 90 degrees to the left, from BAM, it is Ngangoue Alain.
Thank you. Hello, everybody. Today, we're going to talk about the component anatomy, 90 degrees to the left. My name is Alain, and I come from the Congo-Brazzaville, country in the middle of Africa. I live in Paris, and I work as a software engineer at BAM. And you can join me in my social network. So, as I say, we're going to talk about the component anatomy, which is an empirical and descriptive approach of the architecture I've been working on for many months. It's highly inspired from the layered architecture, the clean architecture, and the atomic design, and firstly made for junior developers. So in this talk, I will start by relating the origin of the component anatomy, and then we are going to compare both programming and construction industries, because I have a conviction that developing a mobile application is quite similar than building a digital house. So I will explain you how I switch from my old approach of designing a component to the component anatomy itself. And then I will share with you the potential usages and the feedbacks I started to receive. As I said, I work at BAM, and at BAM, before developing any features, we start by listing any updates, all the updates, to apply to the code in order to deliver the feature in the best delay and with the expected quality level. And we call this exercise the technical strategy. Okay. This exercise requires to anticipate the complexity of the code to be developed. And for many reasons I won't enumerate here, the strategies of my team and I was not perfect, and the collaboration was not optimal. So it led me to seek for a tool that could help us to visualize the complexity of the code, to enhance the quality of the workshop, and to get better scheduling of the work to be done. In addition to these problems, I was also thinking about bugs. Why bugs? Well, in a previous project I've been working on, we faced many issues with cross-screen features, and I noticed that these issues were only related to a bad architecture, or to be more specific, to the absence of a global architecture. For instance, you know this kind of moment when you change a part of your code and a completely different section of your application is broken, despite the quantity of unit tests. So we have many things like this. We have many violations of the single responsibility principle. We have many pieces of spaghetti code. It's not that I hate spaghetti, right? It's just I don't want them in my code. Okay, it's all. So after analysis of all these problems, I came to the conclusion that it was all about architecture. That's how I introduced the concept of architectural bug. Okay, so at this moment, I also developed the conviction that if I could draw the data flow of my components, the probability to introduce a bug will be reduced to 0. Because in my opinion, a bug due to such a bad code can be often reduced to a data flow that is not properly identified. So since it was about architecture, I tried to read my whole engineering lessons, and all I found was about UML diagrams, architectural patterns such as MVC, etc., solid principle, but I was not able to use them to help my junior developer. So I decided to completely, before that, all these tools are really relevant, but they require a great level of abstraction, and in the first place, and a certain experience of coding. So I was not able to use them with my junior developer. I started to look away to find something, a tool that could help me to describe the content of my components. So don't ask me why. My brain made me think about the biology. Okay, so I look at there. Just before biology, I wanted to focus on the architecture definition from Wikipedia, in which put an accent on sketching and building. Okay, so I was like, what is the equivalence of sketching and building in the programming industries? That's where I started to look at other industries, and in particular the biology one. If you look at this picture, you can see how biologists proceed to the dissection of the human body to understand its internal behavior. So I was looking the same thing, but for my components, and I was not able to find it. By the way, you understand now where does come from the anatomy in the component anatomy. So I keep on looking after other industries, and I came to the construction one. And as you can see, I'm not an architect. You are not an architect. But if you take a look at this house plane, you are able to understand what is being done here. Okay? You have a pretty idea of how the different structures will be arranged together to get the final result. You also have an idea of what kind of object you will be able to move inside the building through the doors and the windows. So that's it. This is the kind of thing I was looking for. So I keep on checking if there was not other similarities in both industries. And I noticed that in both industries proceed to sketching, to prototyping, and to building. But if you take a look at the construction industries, you will notice that at any moment of these 3 steps, you have a pretty idea of the internal behavior of what is being done, but not in the mobile application, not in the programming industry. So doing this comparison, I learned something that is really interesting, which is that unless you are skilled enough, the UML diagrams won't help you to design complex components. So there was a need here for a tool, a simple tool, a junior developer can manage easily. At this point, you could ask me, what happens if I'm not able to predict the behavior of my components during the design step? Why is it wrong? Well, I noticed that many developers will see the result of what they are coding only after many minutes or hours of work. So since many developers work without sketching, planning their job, it results in spaghetti code and many bad practice even for skilled developers, and that's a problem. So I keep on looking for similarities because I got that feeling that I was on something. Look at this beautiful mobile application. Okay, I'm not crazy, right? This is a mobile application. I will explain you why. When I see this building, actually, I see a set of functional blocks that communicate with each other. Okay, and by functional, I mean a specific action or a group or a specific group of actions. In the programming industry, we call it a use case, for instance. Okay. That's how I started to develop my conviction that building a mobile application was similar to building a digital house. Okay? So let's take a concrete example. The kitchen. At the house scale, the responsibility of the kitchen is to manage food. Okay? But at the kitchen scale, managing food doesn't make any sense, since everything in the kitchen is designed for managing food. So there is a need here for sub-specialized function, like freezing meals, storing ingredients, or doing the dishes. Okay. Along with the sub-functions, the kitchen organization allows us to move humans, goods, waste, meals, etc. Okay? So by doing this, we just introduce the basics of the component anatomy that are the structures and the flows. And you have the same thing in your code. Let me show you how. Rooms and structures are similar to functions or components in your applications. Flows are your data flows. And in the flows, we have two kinds of flows, the explicit one and the implicit. The explicit are visible. That means in this room, if someone is crossing the room, you will see him. Okay? It's an explicit flow. So in the kitchen, you have humans, meals, waste, etc. And in your application, when you pass a parameter to a function, you see the parameter you are passing. So it's an explicit flow. But in the kitchen, you don't see water, light, or gas unless you play with switch, tap, and etc. The same way in your component, you won't be able to get the result of use query or use context unless there's hook are triggered at the when the component is mounting. Okay. Donc the same way we have tap, switch, and lamp to trigger the opening of water, light, and etc. The same way we can send command with mutation, set state, dispatch functions. Okay. So let's take a break here. How can we profit of it? Okay. I told about the problems I had that led me to compare both industries, but I didn't explain what was my whole design process. It's really important to understand what follows. When I joined BAM, I have been taught to proceed like this. When you get the mockup, you divide it in horizontally, and for each part, you take the result of the UI workshop. Excuse me. Oh, sorry. You list mockup assets like images, icons, etc. You list UX behaviors like animations. You list backend dependencies like API calls. You extract the components and their properties. And in addition of this, you need to think about the existing code, the specific rules, and the side effects. This is a lot, okay? So it leads me to the first problem I noticed, a hard mental work. Okay. So to get out of this awkward position, you better develop a strong process to guarantee you won't forget anything. The second problem I noticed is the hidden complexity. If I can try this analogy, drawing the curves of a car, of a vehicle, won't tell you the complexity of its engine. Okay? So the same way, when you are using this approach, you know more or less how many components you need to develop, but it doesn't tell you how you need to develop this component. So there is a problem, because we need to see the complexity, the whole complexity, during the design step, and not during the development step, because it would be too late. Oh, sorry. So to not be trapped by this kind of complexity, people used to make an exhaustive list of checks, like where does come from my data, what about the login state, are this component already developed, etc. Okay. but few people will ask about background behaviors, such as, do I need a context? How my login state is propagated to the views, how many formatters, adapters, or services are required. So where stands the complexity? The coupling is on alert. Okay, many architectural bugs comes with times in badly designed applications. They result in a poor ability of the tech designer to detect them during the design step. It does not mean the tech designer is not skilled at all. It just illustrates how complicated is it, how complicated it is even for a skilled developer. And the last problem is the lack of global architecture. If, for a reason, you want to go faster using parallelization, and if you don't pay attention to the global architecture, you will get 5 different architectures in the same screen, okay? And it's not really good for the code-based maintainability. So having this understanding of the construction industry in one hand, and knowing the problem I was facing in the other hand, I asked myself, what will happen if I turn my screen about 90 degrees, like in the Xcode render? Then I will be able to see the data flow crossing the components. That's it. That was what I was looking for. So I just had to sketch a vertical section of my components, turn it about 90 degrees, and it was done. So the 90 degrees to the left come from this operation I made to change my perspective when extracting informations from a mockup in order to develop the given component. So now you understand the origins of the component anatomy. Let's see together how does it work. Okay, the component anatomy is a design process with, in 3 steps, the layering one, the data flow analysis, and the fabrication plan. Let's have the change email screen. So the first step of the layering is to expose what I call the hardware context. Actually, if you rotate your mobile device about 90 degrees, you will notice that your JavaScript applications interacts with human sensor in one hand and captors in another hand through to what we call the bridge in the React Native. Doing that will help us to define 3 kinds of components. The UI one that interacts with the human sensor, the data one with the captors, and the business, which is responsible of implementing the business rule. And you can recognize a similar pattern in MVC, MVP, and other similar architectural patterns. Defining these 3 kinds of components will help us to clearly identify their scope in terms of architecture, because we are applying the single responsibility principle, only one reason to change. In terms of quality, because unit tests are simple to write, and in terms of maintainability, because there is no more space for spaghetti code. Sorry. So how to apply it? After having exposed the hardware context, we need to expose the layers. The rule is really simple. A component that contains another component defines a layers. So in this example, the change email screen will be the root layer, and we have a middle layer for the email form and a leaf layer. So behind the root layer, we have a background layer for the authentication context provider. This is one way to do that, but you can have a different approach. If, for instance, in your project you have an email field that will be used at any places, you can decide to create a layer for the email field, and this will be the way you do it. But for the purpose of this, this presentation, we will just keep the first model. So after having exposed the layers, we need to expose the components. Okay? To do that, we just need to encapsulate, to choose the way we are going to encapsulate the components in order to build them. So this step is really relevant because this is where you choose your component strategy according to the atomic design and the level of reusability you are targeting. You are also able to see the depth of your components. You can see the props drilling problematic. You can see the prop drillings in advance. You can anticipate the need for state management, and etc. And beside of this, I have my fabrication plan where I note in yellow boxes the different tasks I need to do in order to implement, to create or update this component, these structures. When we know which structure we want, then we can try to draw the data flow. How does it work? There is 4 kinds of data flow. We have the display data that go to the user, the event that come from the user, the request that go to the captors, and the response that come from the captors. Okay. So in our example, we are going to search for the. We are going to expose one event, and to do that, we are going to look at the mockup and see what component is able to trigger an event. In this case, we have the email input. So we draw a green row for the event with the circle that represents the handler function. And then after, we close the circuit, okay, by having a data flow that crosses at least two structures. So in this case, we know that an email input needs a state. So we invocate the setter, the circle in blue, from the onChange handler, and the email state will iterate the email input. Okay, so we have a circuit. Closing the circuit is really important in the component anatomy because an open circuit represents an unachieved job or a potential bug. So closing the circuit guarantees you are controlling totally your data flow. After that, we can check the other side effects of this event, like the possibility to have an error text if the email is not correct. So from the onChange handler, I will invocate the validate input function that will invocate the error state setter. Okay, but if you are a React expert, you can challenge this misconception because we don't need an additional error state here. Okay, actually, with the component anatomy, you can see why adding a useless state in the data flow is a bad thing. In fact, each structures involved in the data flow will increase the time response of the component. Okay, so will increase the time response of the component because each structures come with a response time cost due to the function stack, the memory allocation, and many other things like this. So I will fix my design and just invocate the validate input function from the email state and iterate the error text component. So I will do the same thing. I will keep on following the side effects of the same event to iterate the submit button, because the state of the submit button depends on the state of the validation of the email field. Okay. So when I'm done with all the side effects due to the text change event, I will restart the same thing with another event. So like this, I will draw any circuit that I need to do. And when I'm done with these components, I go to the parent, and in this case, I will define a use change email mutation that provides me a mutate function I will use to iterate the unsubmit property. And on success, I will invoke a function that navigates to somewhere I want. So this is the data flow analysis. By the way, you can see how why analysis the data flow is better than just divided the screen when you want to dispatch the work between many developers. Actually, relying on the data flow will help you to minimize the Git conflict, the number of Git conflicts. You will minimize the dependencies between the both parts, and you will maximize the parallelization between developers. So it led us to the third part, which is the fabrication plan, which consists in just reorganizing the different tasks I have collected in a graph of dependencies, and that's it. We are ready for the development step. For instance, this is an example of the fabrication plan we just made in my current project, where I was able to put 5 developers on 3 applications that communicate with each other. Okay, so the analysis of the data flow helps us to make it clean and to be confident in the development of that complex feature. So we are close to the end, and I wanted to share with you the potential usage of the component anatomy. Actually, you can use it to design a component, or just to have a technical discussion with other developers. You can use it to teach any component-based technology like React, Angular, or Vue.js to young developers that to help them to create a mental representation of what is happening into the code. You could even create a no-code app generator based on the Lego approach. And there is a last usage I wanted to show you, which is the computation of the architectural response of a component. Disclaimer, this is completely experimental, okay? It's not proven yet. But I have an intuition, I got an intuition. I thought that since component anatomy focused on circuits, I could then apply the same rules than to electrical circuits, okay? And one of these rules is the possibility to compute the time response of an electrical circuit. So it could help us to define a new unit that we could call the architectural response, which is defined as the time response of the equivalent circuit, and will measure the inner component performance. Okay. However, computing the architectural response of a given component will require to know the weight of the structures involved in the data flow. Okay, so the same way we have the impedance of a component in the electrical circuit, we could define a second unit, which is the structure impedance or the structure weight. And we could use the cyclomatic complexity or any arbitrary number according to the strategy, your computational strategy. And this element will will measure the component performance when invoked by another component. By doing this, we have just introduced a new formula, sorry, that say that the architectural response is a function of the different structures impedance. And you can recognize that it's just a generalization of the known function UI equal function of states. So how can we, I was thinking about a practical thing, and I was like, if we could have a VS Code plugin that compute the architectural response in real time, it could be really good, because during the development step, you can you could define architectural rules the same way we have linter rules, okay? And one of this rule could be for any component, if my project, I want them to never reach a threshold or a certain value, okay? So it could be really interesting for people interested in the architecture, and it will avoid to have to put so much energy in optimizing application after we have been developing them. So I received feedbacks from many people, and Antoine, a developer at BAM, told me that he was able to reduce his coding time from 1 hour to 10 minutes, because he took the time to draw the complexity of the component, and after that it was really easy. I got other feedbacks that told me that after been using the component anatomy, it was really easy to plan a collaborative work. And another example is one of the dev of my team who was not able to design a complex form. So after we draw the data flow of the component, he was really confident, she was really confident, sorry, to develop the component. So that is. Yes, I started to create a kind of standard of the symbols I use in the component anatomy, because I received other feedbacks that told me, oh, it could be great if any developers could use the same symbols to understand the same thing. That avoid confusions when we are reading the document. It is available on my GitHub account. It's totally experimental for now, so if you want to develop your own convention, be free to do that. So in conclusion, in this talk, I show you how I tried to solve my initial problem as a tech lead, and then how it led me to build an approach that it integrates the component design thanks to the structures. It takes in account the testing consideration, and it provides a better scheduling of tasks based on the analysis of the data flow. Working on this method taught me that a big part of problems we have when going in production are often linked to the architecture. So I think about performance issues, architectural bugs, issues with the job parallelization, and many things like this. So keep an eye on your architecture. I don't mean the folder architecture, but the real architecture of your application. And maybe you will be better in what you're doing. So to be honest, I don't really know where I'm going with this experimental method, but I know for sure I will keep on working and improving it while it helps me to be more efficient in my work. Thank you for your attention.
Whoa. Thank you, Alain. Such an insightful presentation. And for our last talk today, something that I already hinted at in my keynote, FlashList. Make your list faster now. From Shopify, Marek Fořt.
Hello everyone, my name is Marek Fořt and I'm a software engineer at Shopify on the React Native Foundations team, and I hope everybody still has some left energy for the last presentation, which will be about FlashList and about how you can make a list fast now. So this is a tweet from Mark and it reads, "What if React Native ends up holding us back?" Hold us back? What are you rendering? A list of cards with checks in them. Now, of course, this is a bit of an over-exaggeration, but there is this sense in the community and outside the community that lists still pose a foundational problem to create performant apps. At Shopify, we've also hit issues with flat list and with, especially on low-end Android devices, where, as you can see, the FPS is non-existent and we have huge blank screens, and this isn't just not the user experience we want for our users. So we need a faster list, FlashList. But wait, what about recycle list view? Why build a new list when there are other alternatives in the community? So the advantages of recycle list view are that if you implement it right, it actually is really fast, especially compared to flat list. It is also highly customizable, so you can achieve almost any layout that you would want to achieve. And it is also very well tested. It has been around in the community for a bunch of years, and it has been used in production by small and large companies. But it has also a couple of shortcomings. Especially the API is quite complicated. The API surface is really broad, and while you can achieve almost anything with it, it also means that the learning curve of using this list is quite steep. Swells with dynamic heights also pose quite a bit of a problem if you are not able to compute their height in advance. And during a first render, there are also layout spaces, which manifest as either spaces or when items overlay each other. Okay, so recycle list view doesn't cut it for us, so let's build FlashList. The main goals of the projects have been primarily around performance and developer experience, which comes down to high frame rate, UI and JS FPS, and also being able to minimize display of empty items. And, as I mentioned, a good developer experience, so it must be easy to use. So the FlashList API we've come up with is this. It is very similar to FlatList. A lot of the props are the same. This makes the migration extremely easy. You don't have to relearn what you've already learned with FlatList. And we also consider FlatList API as a good developer experience, so we did not feel like reinventing the wheel. Dynamic heights, no sweat. You can use the same FlatList API and still get really high performance. So how, and maybe why, is FlashList so fast compared to FlatList? Maybe let's start looking at how FlatList works under the hood. It uses a concept called virtualized list, which in a sense means that here we have a couple of items that are displayed on the screen, labeled as viewport, items 4 to 6. And then we have a couple of items that are in memory that the user has already scrolled past through. And then we have a couple of items as well that are preloaded. With FlatList, the number of items in memory is generally pretty high. But if you scroll far enough, you also get into a point where you want to free up some memory. And that's where virtualized list comes in. And instead of removing the items, it just takes the item and removes all the content but keeps the size, so the list kind of doesn't change its scroll position. Now this means that the memory footprint is at a manageable level, but as we scroll up and down, it doesn't matter. Unless the item is already in memory, it's always rendered from scratch. And that means creating a lot of objects again and again, which is not the most efficient process. As a visualization, you could imagine these IDs as instances of individual cells, and as we scroll, we just keep creating new ones and new ones. Okay, so to sum up, FlatList uses virtualized list that replaces cells with empty content to keep the memory footprint somewhat low. And as we scroll, cells are always rendered from scratch. So FlashList, on the other hand, has also, of course, a couple of items in the viewport, 2 to 4 here. It has a couple of items as preloaded, although the amount of them is usually very low. The default is 300 pixels of draw distance. And then, most importantly, there is a concept of a recycling pool. And so, as we scroll, the items are put into the recycling pool, and then when we need to load more items, instead of creating them from scratch, they are put out from the recycling pool and into the list, and they are just re-rendered. That means that, for example, if only a title changes between individual items, you re-render only that title, and you don't need to create a whole new JavaScript object, and you don't need to also create any new native view instances. As a showcase of this, you can take a look at this example. As we kind of scroll, we get to see that the items are put into the recycling pool. And as we get to items that are not preloaded, we start putting the items out of the recycling pool back into the list, and they are just rendered with new content. And so the cell IDs here represent the individual instances, not the content itself. We also needed to fix an issue of the first render. This is how recycle list view manifests this issue. So this is a slowed down version of it, but you can see that the items in the first render are kind of over each other. And then after recycle list view, gets the actual sizes, it puts the items as they should be, and they are not overlaid over each other anymore. To get deeper into this problem, on the left you have the expected layout. So RecycleList View has a prop called estimated item size, which you as a developer have to input, so the RecycleList View has a sense of how big the items will be. So in this case, let's imagine that the item size would be, for example, 100. And so it puts number 0 at 0 pixels, number 1 at 100 pixels, number 2 at 200 pixels, etc. But then we have the actual layout where item number 1 has a height of 200. But the item number 2 still assumes that it was 100, and so it puts it a little bit higher than it should, and thus we have the visual regression that we've seen in the example. What we've introduced to cover for this scenario was a native view that synchronously goes through the layout and with a custom algorithm goes through any possible spaces or items overlaying each other and kind of makes up for these regressions. So with FlashList, we get no lag. So the FlashList implementation, we have an API that is extremely similar to FlatList, although there are some props that do differ. We have a native view for the first render, and we've been able to achieve performant dynamic cell heights. And additionally, we do use RecycleList View as the init engine, but we built on top of it to achieve that API and also bring more performance out of the box. So let's get into some metrics. The metrics have been collected with a device, Motorola Moto G10, that has a very slow processor, Snapdragon 460, and also there have been recording on the background. So don't look at the absolute numbers, but I do recommend looking at the comparison between FlatList and FlashList. So let's first look at FlatList UI and JS-FPS using the performance plugin that we've already seen a couple of times at this conference. So as we start scrolling, we get to see that the JS-FPS drops very low, and UI-FPS doesn't stay close to 60 as well. And at the end, we get to a score of 39. Average JS-FPS is 11.8. Average UI-FPS 44. And also, quite importantly, we get almost 2 seconds of thread lock, of JS thread lock, which means that for almost 2 seconds, the user has not been able to interact with the screen at all. And we also believe this example kind of showcases a normal kind of complicated list. We have some remote images and a couple of elements in each item. We have dynamic heights. So if we look at FlashList, we never get that low with the JS-FPS, which is quite important. And the UI-FPS, only for a split second, actually drops under 50. And so we get an average JS-FPS of 49, which is over 4 more times better than FlatList. We get UI-FPS of 58, which is pretty close to 60. And quite importantly as well, we get no thread lock compared to almost 2 seconds. We also measured blank spaces with a custom plugin that you can check out on the Shopify React Native Performance repo. And as the name suggests, this plugin gathers the average blank space and the absolute blank spaces over time. So with FlatList, even though we, for a couple of seconds, can't even interact with the screen, we get these huge blank spaces that basically span the whole screen. And so the average here is close to 200. And as I mentioned, sometimes it spans the whole screen. With FlashList, on the other hand, we get a different story. the blank spaces are almost eliminated, and they never get to a point where you just cannot see anything. So we are around 45 of average here, with scrolling, I believe, unnaturally fast, which if we compare it to FlashList is basically 7 times better, which is quite an improvement when considering that the only thing we did was change a name of the list. And I would also like to do a quick demo. I am curious to see how it's going to break, but we will see. So we again have a Twitter sample here that you could have seen in the previous videos, and it's currently implemented with FlashList. So we conclude the performance is not good enough, we want to do something better. So what we're going to do is just add the package to our demo. We will install it. Since we do have a native view, we would have to also run React Native, run Android, or run iOS with pod install. But I've already done that, so we don't wait here for 3 minutes. The next thing we're going to do here is we will rename FlashList to FlashList. And we're going to remove this import since we don't need it anymore. And okay, so that's it. We have a couple of props here, so it's not like the list has only one prop. We have a header, we have a key extractor, which, as a side note, is not necessary for FlashList, but it does help in some scenarios. But we do give it a warning, so let's display that. It tells us that the estimated item size for FlashList prop is not defined. I've already mentioned this prop, and in FlashList this prop is used only during the initial render to get a better idea how many items it should render. And so if you give this item, if you give this number too low, then FlashList will try to render too many items, and the first render can take a little bit longer than it should. The good thing is that based on the items we already have, we can already get the number. So it tells us that we can use a number of 149. I'm just going to round it up, and let's do 150. And when we refresh, we can see that we no longer have any warnings, and we could use this list in production already. One thing we've seen a couple of times as well is that users sometimes have a key in their top-level item components. So let's try to imagine we had this kind of regression and put a key here which is based on the ID of a tweet. This means, performance-wise, that we no longer have any benefits of recycling, since whenever the key changes, the whole component unmounts and we have to mount a new one, so the recycling goes in vain. One thing that's always good when doing any kind of performance metrics is to get rid of the JS dev mode, so I'm just going to do it there. And we do have a hook that kind of helps you also with getting better numbers out of your components, since we do provide some metrics out of the box. So we have a hook that's called useBenchmark, and it has a couple of parameters. One of it is a FlashList ref, so we'll provide that. Oops. Yeah, Copilot, thank you. And we also need to have a model, and I think I'm missing an import as well. Okay. All right, and now we can just pass it to FlashList and to the benchmark. The other thing we need to pass to useBenchmark is a callback where we'll need to process the result that the benchmark gives us. So one thing we could do is display an alert, because we are we are not in a dev mode, so any logs will not show up. And we also need to rename this. And the result has a couple of parameters, but what we're going to use is formatted strings. We just want to display it. Last thing this hook gives us is an on-blank area callback that we need to pass to FlashList as well. And I believe that should be it. So what this hook will do is it will try to scroll as fast as it can all the way down and up, and it will gather metrics for us. So let's see how we fare with the key parameter. And as you can see, it's not very good. We get lots of blank cells, and the FPS the average is 5. So, yeah, not really good. We also get a blank area. That's maximum, I believe, the height of the device. And we also get the cumulative blank area as it went through the list. We also get a couple of suggestions. One of those is that my average JS FPS is low, which I agree with, and it tells me I should optimize my components, which is fair. It also gives us other suggestions, like the data count is low, because you kind of want to have a lot of data to get more stable numbers. So we do have a hook to just multiply the data, so you don't have to do that yourself. Other suggestions here are, for example, that the estimated first item offset can be set to kind of get a better estimate for that first render and also for a better initial scroll index. And it has a more precise estimated item size based on the large number of items, which we could set to 160, but I will skip that step. So after lots of thinking, we'll find again this key. We will just remove it, and let's see what the results will be without it. So again, the hook will go through the whole list as fast as it can, and again, try to get metrics. We get from an average FPS to an average FPS of 30. Considering this is a low-end Android device, I am doing recording, and also I'm scrolling unnatural scroll. That's quite good. And also with the key, that's probably the performance you could expect with FlashList. So 6 times better. I believe that's quite an improvement when we've just changed the name. And so let's get back to the presentation. Is FlashList production ready? Let's get this question out of the gate. So let's compare how our shop app looked with FlashList and how it now looks with FlashList. Before it was almost at the point of unusable, whereas now it is extremely snappy with just minimal blank cells on a very low Android device. So if you use iPhone, then you will not see any blank cells for sure. It is also currently used in all of our apps. So it's used in Shopify Mobile, Shop, Inbox, and POS. So we've tested it quite well at this point, and we've also heard a lot of good things about it at this point from the community. So we do believe it is production ready. But if you do have some additional feedback, feel free to share it either here or online. And you can also check out the project as it's open source on GitHub. So give us a star, open an issue, open a PR, and that's it from the presentation. Thank you very much.
Thank you. Wow, what a conference, huh? Thank you. It was a pleasure to be here and to be your host. At the very end, I have a few last words. So first of all, thank you, ColdStack. Thank you, ColdStack, for letting me be a part of such an amazing event. And I cannot imagine a better forum to receive such valuable React Native insights and experience. And all of that in just 2 days. To all of the speakers, thank you so very, very much. I was sitting right here below the stage for all of the talks, but I know that I will be re-watching them very, very soon. So next up, I'd like to thank all the participants. Yeah. This whole conference is for you, for the community. So we are glad to see your questions, reactions, and comments on Discord and Twitter. Make sure to stay in touch because we'll be publishing those talks very, very soon. We also publish the React Native Show podcast, and I hope to see you all in the React Native EU 2023 next year. Yeah. So I'd like to also thank the organizer crew, our marketing department, and the tech team. The planning and the execution was really flawless, and I'm glad to be working with you. Yep. And at the end, I really don't like to say it, but I think I have to. Dear community, the React Native EU 2022 edition, the only React Native focused and community-driven conference, has officially come to an end. Thank you all again, and remember, we are always hiring. Cheers.